around. Hospitals are the worst place to be. They are not for healing. They simply patch you up there and then they send you home to actually rest and heal. I've always found hospitals to be the most hectic places. They're not fun. Learning to walk again was fun. Very interesting definition of fun. We will get biggest dickus on BTS soon. By the way, burn the subs. If you hear the Twitchers talking weird, burn the subs is this thing on my wall. It's this big weird thing on my wall. And it is a blue laser powered subs board. So if you subscribe to me on Twitch, the name will automatically be etched onto this fancy block of wood. It is designed so that the utmost fanciness and care is robotically given to names such as Big Fart Dick 42069. Because that's what Twitch is like. so that's what the board is. I have not had the board working since the pandemic. It was check 1, 2. Okay, there we go. It was, yeah, the burn the subs has not worked in quite a while. Cervical laminectomy with C3 to C6 fusion. My ligaments and slip disc were crushing my spinal cord. Is that one of the ones where they do the 1-inch incision and then they insert like a titanium bar or a whatever? I know it started 6 years ago. I know it's been a while on this project, and you know, we have made progress. I've done quite a bit of stuff to burn the subs. It just needs a wiring harness now. So I need to break everything down wiring wise and redo it with better wires, which is not really an enviable task. And so I've decided to go a little bit variety on the projects, and then got kind of stuck with the simulator thing because it's becoming its own animal. It's a whole thing. It was 100 years ago. Well, it'll be working again soon, and then I'll apply for front page. By the way, I use silicon wires these days. Yeah, that's what I exclusively buy now. They're good, although I'm a little fed up with them, to be honest. I don't know. I guess they're still fine using all silicon wires for everything. It's just they collect dust really easily, and then they don't slide against each other very well. So I don't know. I'm debating if I want to continue with them for burn the subs. Probably will. They're very easy to solder, but Teflon's, I don't know about Teflon. I've already got too much Teflon on my balls. But yeah, I want to get the simulator setup thing going a little bit more because I've got a great idea for it and I want to see it. I want to actually see it. And I've had this simulator stuff I've had longer than burn the subs. So I kind of want to get that all hooked up to something, because it has just been collecting dust here. Cut from the base of the skull to the top of my back. Oh, it's that. Wow. So are you like turning like Val Kilmer now? Is that like? I don't mean. Well, he's not alive. Val Kilmer as Batman, who would do the bat look around. You have decent motion. Oh, that's good. Good. God, 8 screws. That's crazy. What's up, Madam You? Bro. What are you broing me about? Yeah, it was one big rubber piece, so if he moved his head, it would like wrinkle. It looked terrible. So yeah, we're back to microcontroller stuff today. Sweet art house wide shot. I'm going to use a diopter and get focus on both halves of the screen in some kind of a jarring art house shot. I do that when I wear my horse mask. I've never bought one of those. I have all kinds of other stuff, but never the horse mask. That headlight switch is vexing me. I do not know where it is. I have no idea. There's a couple places that I can kind of dig out. Oh, the Joel Schumacher bat nipples, yes. Look up at your chat, see bat nipples. Question life choices. Feel better about life choices? Anyway, I have been looking everywhere for that switch and I just I cannot fathom where it is. I do not know where it is. I don't know where it is. I don't know when the last time I saw it was. I don't think it's like behind. Hold on, I'm going to do a little cell phone trick here. No, it's not back there. Nope. I don't even know when when did I last touch it? I have this weird sinking feeling that I found it somewhere and that it got all scratched up, and so I threw it in the garbage. But thinking, I'm never going to do anything with this. Why would I keep it? But that might be me just creating a memory, or it would have been a dream of some kind that I had, because I don't think it really got scratched up. I don't think. And it's possible that maybe it was on this edge of the desk here, and it just kind of went over into there, and there's all kinds of like sharp stuff there. It's like grating and stuff, gratings and stuff that I need to move. So maybe I'll find it if I clean out that area. I've already got a massive cut on my finger. Well, it's not massive, but it's like right where all of my nerve endings are. This big gash that I got on my finger, because G-Skill shapes their RAM like gas station knives. Like I think they share a designer, because this is just unacceptable. Why does my RAM need to look like that? Because primarily I have to push down here in order to seat it. So why are there spikes, G-Skill? What is this? It's not a security system. It's just a way to cut yourself. That's all it is. Unacceptable. He has RAM! Yes. Hey, this is sent in by a viewer, man. I'm not even going to name them at this point because I don't want them to get, harassed. They sent this RAM, and by the time it got here, RAM was super expensive. That's the timing of that. They sent me a couple sticks when RAM was cheap, and overnight, well, it was a couple days, maybe like a week before it got here. When it did get here, RAM was super pricey. What is, okay, DDR4 2400? I shudder to think. Pre-owned, $11. Okay, that's not so bad. G-Skill, Aegis, 150. I don't know if it's super expensive for this stuff. 4 Ripjaws. That looks like what I have. $300. Okay, well, these were sourced ethically, but they will not be. I'm not going to sell them. I'm not going to do that because that feels unethical. Selling them feels unethical. But apparently this stuff is pretty expensive nowadays. I should probably stop handling it when I don't have any kind of static mitigation going on. Go rub my socks on the carpet and start touching my RAM. That's what I do for a good time around here. That's what happens when you ban drugs and alcohol. So hey, is this something that would work? If I took my Dremel and a drill, and these are like hardened driver bits. The problem is, I like the drive on this, right? I like that. It's the one that lets the bit kind of wiggle on the end so that you don't have to be in perfect alignment every time. But it doesn't have the little locking cut. And I know this is hardened, so if I take the Dremel and I use a grinding bit and I spin this, can I grind this feature into it? I think I can. I don't know how long it would take though. Or if it would be worth it if I could just find one of these bits that locks in, because I don't know why the shorter ones didn't have that cut. So this one I use, it's absurd because it sticks way far away. This is fine for like, what do you call it? Regular old sockets. But the socket that I'm using in this is a ball end hex thing. So it's actually one of these. Here, I'll just grab a different one. The one that I have out is the one that's actually meant for, it's what I use to take apart the frame rail stuff. And I just bought these. I love them. I love them. Because they're these long hex bits. This one's a little absurd. It's kind of weird and small, but they're all ball-ended and they have the hex drive. And so this goes into my impact gun so that you can loosen stuff up really fast. I don't put them in with the impact gun because that would strip threads. I think I'm too reluctant to do that. If you do really want to put stuff in with a like an automatic thing or whatever, you set the catch on the drill to have only a certain amount of torque. But I would rather do it with the T handle, because the T handle, I know the feel of how to like get stuff super tight. This is for disassembly, and so it can impact a little bit and then just spin really, really fast. And then having it on the misaligning 1/4 inch, whatever it is, socket end, makes the tool really useful. But having it on the extended one is just absurd. It just sticks way too weirdly out and it's too long. So what I want to do, oh, by the way, and if you have this on there and you are disassembling something and it does do the impact, it can sometimes on hexes, it'll misalign a little bit and start to wear away at the hex bolt, because hex bolts are really bad at taking torque. They're quite abysmally bad. I wish it was Torx TORX bits. Hold on. That beeping is me. That means my insulin pump's out of insulin. We're going to have to do a pump change here before we start stream. So go over to dash, pod management, deactivate, next. So when it does do that little bit of over torque, what'll happen is it'll pull out of this because there's no locking thing on it. This one will appropriately, you know, pull itself out of the hex socket, or it'll pull the wrench socket off. But I would like this to lock. So I guess what I need to do is I need to find an appropriate roundelated, you know, roundy kind of shape grinder, like one of those stone Dremel grinders, or maybe just a little sanding attachment, and then spin this, spin this, and lower the Dremel very carefully for a long time in order to create that feature. All right, so pod has been deactivated. I now need to take off my shirt, so you guys are not going to be able to see. Well, actually, I don't need to fully remove my shirt. All I need to do is take off the outer shirt so that I can get to my arm. Just hammer it shut. I don't think you understood anything of what I just said. Let's get insulin. Apparently they switched me to Novolog. That must be the new formulation. I don't know, Novolog versus Humalog versus Humalin. I think they're all the same thing. They're just different prices. All right, so look at this, look at this. New insulin pump, who dis? And I will mute for a minute. Well, actually, not yet. I will mute in a minute. We're going to be doing some programming today. We're going to keep going through that tutorial. I know the game because I play it. I know your game. This is Space Cowboys, who is a music collective from, I want to say San Francisco, but I could be wrong. And they do a lot of Burning Man stuff. That's where I sort of got to know them. A friend of mine, Scotty, loved to find them in the desert and party out. And it is sort of this brainless electronic music that I can put on that's a little bit poppy. Fun little deep house every now and then. But it's good for the background music of a stream because it's semi-popular stuff, but it's also probably pretty copywritten, so YouTube doesn't get to hear it. All right, so what this is an Omnipod Dash, which is a generation behind. I don't know if the newer Omnipods work with the Android Auto Pancreas system. They're probably working on it at the pace that they can. It's an open source situation, so who knows if that'll come out. I could probably get the newer pods. I have a huge supply of these right now just because the way I budget my diabetes supplies is so that if something happens to the supply chain, I have some extras so I don't instantly run into a situation where they're sending a fucking ambulance to my house or flying somebody out to give me something like an insulin pump. I've had that offered before. They said, hey, if your pump doesn't work, we could fly somebody out and get you. I'm like, no, I can just go back to syringes for a day. So anyway, I try to be responsible in that regard, but they try to budget you down to the wire on what you can and can't have. So anyway, luckily I've built up my supplies properly. So the day when I upgrade, a month later, I'll probably actually move over to the new pump. This is the older one. The older one does not do management local to the pump. So it needs to have Bluetooth Low Energy to a device that's controlling it. In this case, it's my phone. And then I've also got the Dexcom constant glucose monitor, CGM. The CGM has a little bimetallic wire that goes under the skin, and it calculates your blood glucose level 5 minutes ago, right? So every 5 minutes, you get 5 minutes ago data. And so that all goes into the third-party programmed Android Auto Pancreas system that I had to compile using instructions because it's a medical thing. If they compiled it and they gave you the file, they would be responsible for hurting you if you did something wrong. So in order to be able to do that without running into law, you compile it yourself, you take the risk on yourself. This thing can get aggressive, and that's what I love about it, because I am a giant fat guy. I mean, look at me. I'm not thin. I'm getting there though. I'm losing weight. Weight is going down. That is something that is happening. So anyway, in the meantime, this thing is able to get properly aggressive and keep my blood glucose levels in check. That A1C level that I was looking for last stream, it finally came in. It was 6.8, which is the lowest it's been since 2007. Because I've got a chart of all that stuff. The hemoglobin A1C is it's a measure, not a tight measure, but it is a measure of your average glucose levels over the past 3 months. So you could theoretically calculate what my average blood glucose level was over the past 3 months from that 6.8 number. Hey, what's up, Copper? Sounds a bit much in the first moment. We can fly a pump out to you, but when you think about it, it might be the only way to save. Yeah, well, it's not a life-saving option. It's a prevent a serious situation where when management, like glucose management, changes, that's a very risky scenario. So I guess they wanted to mitigate that for the patient. But I was like, no, you guys don't have to do that. Okay, one sec. I got to mute. Are you doing like lossless quality stuff? Because a bin.q file is not that crazy. We used to do bin.q files all the time. I don't know what program we used. There were all kinds of programs. But there's nothing too crazy about that. You should be able to figure that one out. It's possible that burning software knows what to do with it. I mean, I was using bin files to do the memtest flashing of a thumb drive, and you can also use the bin file to burn a CD if you want to do memcheck on a memtest or memcheck, whatever. Anyway, if you want to do that on a CD-ROM, you can do it because yeah, the bin.q file, it's just image of a disk. Okay. Let's get rid of start soon and get started here. Hello, it is I, O'Baller. Hold on one sec. Let me lower the volume here, man. So, guys, I just tried to load up HighGuard, and you would not believe what happened. Anyway, what are we working on today? Welcome to O'Bother. This is my Twitch channel, which also has a spin-off YouTube VOD channel. If you guys are getting me in your recommendations, I'm sorry. But anyway, what we're working on, now that I'm all juiced up with a new insulin pump and I've got insulin coursing through my veins, I ate a Wawa hoagie ahead of stream, and so I haven't had one of those in a little bit, and they're kind of a carbohydrate bomb. So the indie game HighGuard, I hope everything's okay with HighGuard. Let's go play a few rounds. They shut it down. They shut it down. It was a very bland game, and they just immediately gave up on it. Unbelievable. Sark was playing it last night, and it was very, very funny. Oh, was it 12 minutes ago? That's even more topical. I love it. I thought it was at like 3 a.m. that they shut it down. Anyway, I guess they let it go a little bit longer. Hi, I am your somewhat beach ball shaped streamer. This is the least flattering angle I could possibly give myself, but it does show off all of my giant man baby toys. Also, it shows off my giant man baby body. Anyway, I'm a streamer. Of course, I'm a little bit rotund, right? But we're turning that around. It was 10 a.m. PST. So in Sark's stream last night, everybody was talking about how it was shutting down at like 4 a.m. Pacific. What is HighGuard? Now I want to play it. Look it up on... Oh, never mind. Yeah, so HighGuard was like a hero shooter, and it did like a base defense, like a wall defense kind of thing with like a shield, and you were a hero, and you had different abilities, and you'd pick up loot boxes of guns that were on the map. It was so incredibly formulaic and forgettable that they forgot to keep the servers up. Now they intentionally took them down because there weren't enough players. It just really like it was the corporate version of a hero shooter. And there was no edge. There was nothing cool to it. I don't know. I don't really know much about it. It was probably fun to play. Anyway, we've been working on this simulator setup over here, which is completely devoid of first-person shooter antics. We are slightly more cerebral gamers, and we like to do things like build physical devices that will control a game because we went to the arcade as a kid, and we want to bring back that feeling. This is a really bad camera angle. I have to stress how little I enjoy being filmed like this. First person driver, something like that. Really, it's funded by Tencent. Voice actors have got to work, and they're not cheap. That's what it seemed like. The whole effort was just to keep voice actors in their like SAG benefits. Anyway, my brother drops off this whole ass car seat that is an electronically controllable car seat. I already had the 2 horsepower, 20-pound servo motor. I already had the actual car pedals, and I already had the wheel from a Mercedes. So we bought an electronically adjustable steering column, and I had to connect it all to stuff. These are 4040 rails. These are not cheap, these rails. Unfortunately, these are the ones that you can stand on and walk on. And since I'm not exactly light, I'm not exactly like a tiptoer, right? Well, I actually am, because I've grown up in old houses, so I know where all the creaky boards are. Like, I know how to sneak into a building and not be heard. I really wish my roommates had ever learned those lessons as a suburban kid coming home at night, in the middle of the night, trying not to make any noise? Anyway, so the point is, I bought these giant rails. They look way overkill, and they probably are, but the size delineation between overkill and underkill, there's nothing. There's nothing. The 30-30 rails might do it, but they're so rare that it might have been a mistake to get them, because I wouldn't have much support in terms of fasteners and stuff. With the 40-40 rails, the rails themselves are very expensive, but I can buy packs of hardware to put it together properly, and there's all kinds of support for that. In fact, I bought some brackets instead of making them. I could have made 2 square brackets for the bottom of those the two rails that sort of do the weird angle. See how they're going all the way to the bottom of the rail there? I'm going to put a bracket underneath it to hold it square to the thing, so that when you push on the brakes, all that force is going into like tilting them like that. And so that bracket will take up the brunt of that force, and it's all moment arms and levers. Anyway, I could buy those parts because these are not 30-30 rails. 30-30 rails I'd probably not be able to find. So I ended up buying big rails and making a big man-baby throne out of this whole thing. We have a ton of buttons and stuff. Yeah, I bought that joystick. The Thrustmaster Warthog is now a legendary and expensive joystick, prohibitively expensive. When I run into prohibitively expensive, I go to eBay. So I went to eBay and bought that, likely from a university, because it has this button on it that says laser arm, and there's a couple other markings on there. When I was deciding which one of the Warthogs that I have to mirror image with new parts that I got from some guy from a forum, I was very much considering, it's like, okay, that one says laser arm on it, so I definitely have to keep that. I don't know what those students were doing, but they spent $400 on a joystick for their university project. Like, who does that? You could have just used like a dinky little... Anyway, we're working on this thing. All of the stuff that I have, all the control stuff, all the pedals and the axes and the joysticks and the buttons, all that needs to speak to something that'll make it into like a joystick on the computer, what's called an HID device, a human interface device. HID devices are like when you plug in, you get oh, look, a joystick's plugged in, right? So we got to make that happen with a whole bunch of disparaged, weird parts, things that are hacked car parts, things that are gaming accessories that have USB on them, but will take it over just because. I figure what I can do is make everybody speak CAN bus. CAN bus is an industrial local communication kind of thing. It's used in robotics, in factories, and your car is the best example of the industrial use of this bus system. Cars contain several CAN buses because car systems are stacked up like a totem pole. You have lower tech stuff, they come out with a new high tech thing, and they keep both, and then they pile something else on top of it. This is why tire pressure monitoring systems were a huge security risk for a little while for hackers that had intimate knowledge of the chips that were used in the car. If the hacker has an intimate knowledge of what the modules and the chips are, they can tell the tire pressure monitor to send out a CAN bus signal that will put something in a software update mode. They can update the software, and then that'll bridge over to other CAN buses, because the car company went, wait, we need to know what this is doing, so let's put a module here that has both of those CAN buses coming into it, and then it'll be able to hear if this signal comes, and it'll be this signal. And they don't think about security during all this stuff. Or if they did, it was an old security system, and they an old security methodology, and they didn't update it. So that's where all that car, hackers can crash your car came from. Generally, it's really difficult to do that. Hacking into a car and initiating the ABS system. ABS system's on a different CAN bus, on a super high speed safety CAN bus that's typically kept completely separate from all of the other systems. But if you have intimate knowledge of one of them and you can reprogram it to do your bidding, you might be able to bridge over to that other CAN bus. That's where that comes from. You need to be a PhD though. You need to know, take apart all the electronics and know them. And, there's a lot of proprietary stuff in cars too. So the really impressive Subaru hacking stuff was basically a man in the middle cell phone where you fake being a cell phone tower, and then the person unlocks their Subaru with their cell phone. You get that signal and relay it over to the Subaru. They don't think anything's wrong. The car unlocks. But you get their like whatever encryption keys or whatever from that signal that's going from the Subaru application on your phone to the car. Then they can do things like roll down your windows, which has been done at a hacker conference before. Everybody arrives at the conference. They have the Subaru sitting out there. They get the signal. Everybody goes to the conference. By the time they come back, the hackers have gotten it so that they can roll down the windows. I used to study this stuff for my job, but that was only on like an introductory level. So anyway, we're going to make the least secure of all of these types of car systems because we're making toys. And in fact, we are going to inject chat into the whole system as the hacker with the laptop and the baklava going, I say baklava, I know that's the dessert. I just say that anyway. I don't say the right word because I also forget what the real one is. Anyway, the mask. Here, let me just pull up that images, Google, future lady with corn. You know, the hacker, oh wait, no, that's the wrong, that's the wrong one. No, it's hacker with laptop. That guy. Wait, none of these. And Greek dessert. No. Baklava? Yeah, there's the guy. This motherfucker is going to get into your car using CAN bus. This is basically chat when I'm playing games on the simulator setup, because if we do what I want to do, which is to use a program called Node-RED, it's something that you can run on your Raspberry Pi, which is exactly what I want to do. It'll host this website. Yeah, my neighbor bought me a Flipper Zero. It's the coolest thing ever. He and I were sitting out there talking, and this guy's a former engineer, and he had a Flipper. He's like, I bought one of these Flipper Zeros. I don't know what to do with it. I'm like, well, that neighbor over there is a Hyundai. We could just hack into that car. We could go joyriding in it. And I was like, man, that's cool. I tried to buy one, but they wouldn't accept my credit card. The fraud division spun up. And so like a day or two later, he goes, hey, here, you can have this one. I'm like, what? He just gave it to me. It was awesome. But I don't really know what to do with the Flipper Zero because it does all the hacking stuff that I do on a lower level, right? Like it'll very quickly get you to like listen to signals that are in the air and stuff like that. But like, what do I do with it? I was thinking about setting it up to hack into Wi-Fi, which is like turbo illegal, super illegal to do, but hack into Wi-Fi. And so as I walk around the neighborhood here, I could hack everybody's router and then set up some kind of like a tail scale pipeline of some sort so that I could hook the RC car that my friend got from a free cycle to the simulator with like an FPV camera. And we could drive around the circular neighborhood here from the basement. And then I'd probably flip the car and that would be the end of the stream. But the problem is it's too thick to be like a good universal remote. I know it could be like a really nice universal remote for doing garage door, TV, like all the things that I interact with in my day. I could probably do with a Flipper Zero. Yeah, I was thinking about doing that. It's going to be a little bit of effort to get it spun up. And then in order to do rolling code, clicky things, you have to get different software. You have to find the ones that are compatible with rolling codes. Anyway, the point is Node-RED. Node-RED has this really easy interface where you just deploy a setup, right? You can't see it. It's up in the corner. There's a deploy button up there. And so much like I'm pulling in the Twitch API with a node, I can pull CAN bus in with a node, and I can output CAN bus signals with a node, and we can do all kinds of nodular filtering in order to make different things happen. And I can configure it quickly and on the fly and in a visual manner. So if I have on one side of the flows, I have all of the buttons and switches and analogs and levers, I can then take the flow, cater it, manipulate it, scale it if I need to, and make it do all kinds of different other functions. And I can inject things like signals from the Twitch API in order to affect what's happening on the sim. So I can have lights turn on and off. I can move the seat around in many irritating ways. I can turn on and off the heaters. I could probably just fucking like shake it or something, and I could put a gun on it and just shoot myself in the brain when you guys spend bits, because that's what Twitch seems to want to do. Bother, why don't you have a sulfuric acid spray that we can set off using channel points? Yeah, sure, yeah, that sounds great. Why isn't there a fart spray is the one that I get the most, and it's like, I have to live here too. Like, jeez. Oh, I got this thing. This thing's pretty cool. I finally have a proper decade box for resistors. And this one's cool because it uses those little switches, like the ones that I showed you guys where it does a little counter thing. I don't know what the circuit looks like inside of this. I kind of want to find out. We're going to divert for just 5 seconds here and take a look at this thing. So anyway, that's the project. The project is to get everybody speaking CAN bus, and when everybody speaks CAN bus, I can have the Raspberry Pi with the CAN bus hat be an interpreter of signals, and then just chaos. I think that would be really cool and fun, and then we also are completely separate from any of the programs that are involved with joysticks and stuff like that. Yes, we can bus. We can bus a bus. I don't know what other simulator setups use in order to perform the sort of fusion of devices, but I'm taking my main cues from what we learned from this shifter here. From this thing. This is a real car shifter. This is a BMW F10 5 Series shifter, and it is basically a penguin's wing. It's like a chicken wing that you pull or push, and then you can click it over to the side. This works like 2 devices. One device is a button, a series of buttons. You can hit the P button, P, 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 or you can hit this, that, this, and that, right? Those are 5 buttons. This one is weirdly involved in the functions of the shifter, so this is a weird one. It doesn't seem to affect anything because it's supposed to lock you out of being able to do this until you hit the override, but it's still, no matter what mode we're in, it still tells you what you're shifting into. So I don't know what that's all about. And then there's a way that it kicks back over, like it kicks over to do the plus minus. There's a way that pushes it back over. But again, it's 2 devices. One of them is a bunch of buttons, and the other one is all the lights that can be lit up to tell you what mode you're in. All right, what's inside of this? What? What? Huh? What? Oh, that's weird. It'd almost be better if this were just out in the open. So I guess it's just a bunch of resistors that are connected to all of these, because these will connect kind of like binary numbers. And I guess what it's doing is it's just going down the line and connecting different value resistors. These have to be such a pain in the butt to put together. Oh, is that a little repair? No, what is that? Just a little flake of something. What is that big bridge doing there? Weird. Yeah, hopefully these are precision resistors, but that's a decade box. Basically, if I'm doing anything analog, like with the synthesizer stuff, I will be able to substitute in different resistors to my heart's desire. Oh, look, they had to shave off the 2 posts there to fit this. Huh. Cute. Cute, cute, cute. Old school electronics kind of stuff, except for I didn't expect surface mount. I thought it would be through hole. This is such an old thing. I'll have to see how accurate this thing is. Maybe we'll do that in just a sec. But yeah, what we're going to be doing is trying to use the Arduino Blue Pill. That is predates the incel. I don't want to call it a movement because it gives us too much legitimacy. The terminology that was ripped from the Matrix in order to describe, I don't know, how sad your life is or something, about whether or not you are red-pilled or blue-pilled. It's so bad. It's something about hating trans people, so naturally I think it's subhuman. But anyway, oops, screws are already there. There we go. So anyway, the Blue Pill, the Arduino Blue Pill, is an STM32F103. Why do I know that number? Because I've run into it so much. The STM32F103 is an insanely powerful microcontroller. If you're trying to do a variety of tasks, you can do it really, really easily because that thing has 4 goddamn threads. It works at 70 megahertz. It has no right to be as powerful as it is, but it is also a little bit of a jerk to program. But I discovered that the blue pill exists, and the STM32 blue pill was an effort to get the STM, I don't know, ecosystem to work with Arduino. So I guess 0 means infinite. 0 does not mean, oh no, maybe it does mean 0. Yeah, 1.5 ohms. That's about what these are. So 1 ohm. Oh, that's meg. Oh, we're inverted. We're working like this. 2.2, 2.1, 2.0. Mark. 10 ohms. So that's 1, 2. I don't like that the pluses are below. The pluses should be above. Why did they do this the opposite way? I used to do a lot with the STM32F4, loved it. Is it obsolete? Because like I don't see a lot of stuff with blue pill anymore, and I try not to follow Hackaday that closely, because if I do, I get in trouble because I start ordering parts. I go, wow, that's a perfect project. And then I just start ordering stuff, and that gets me in trouble. Ooh, that one was off by a couple. All right, it's pretty accurate. I mean, my multimeter is not that accurate anyway. I do have a more accurate multimeter that was sent in by a viewer, but it's a desktop kind of thing, and I don't know, maybe one day we'll have room for all of my other equipment to be in here. What are you guys doing? Oh yeah, the strange CDR plays music in a car stereo with CD info, shows up as individual bin files per track, and a Q file on the computer. Yeah. That's hacky method of converting it using MAME, ROM compression software. There has to be a better method. The programs used to be able to use the Q and bin files. I don't know which ones do it though. I don't know which ones. But I am familiar with the format because I used it in the early 2000s, in the late 2000s, and the late 10s. So anyway, Decade Box, cool. Well, add that to my repertoire. I'm just going to throw that somewhere. STM32F104. This is a MIDI pad. This is not a MIDI pad that you can buy, unfortunately, but this is a MIDI pad that I have. You can get offshoots of this, but I don't know what they're called. If you look up like MIDI pad on Amazon, you can find these. They're USB. The advantage to us having this one is for some reason this thing is old enough that it uses an STM32F104, and it uses it in a very predictable way. The USB pins that are also CAN bus pins are put out to USB. So what I figure is we can get the SWDIO using the programming header right there. And that's just right there. It says JTAG on it. It's very convenient. Now, I will not be able to plug this into USB and reprogram this. And by the way, this has a LM1117, so it's just like all the synthesizer stuff that we were doing, which involved, believe it or not, STM32F104 as well. So anyway, we can program this using the dongle, and we will probably have to reprogram it using the dongle too. Obviously, I don't have experience using CD writing software. We're all getting old. We're all getting old. We lived in that world, and now it's gone. Now it's gone. Now weirdos like Copper come in here and he goes, I am a fetus. I don't know how to use CD burning software. Tell me, old wrinkly man who's currently turning into dust in front of me, where has your life gone that you know of CD burning? You make us feel old, Copper. So I want to take this thing over. I want to make this thing blink a hello world. I know what all the pins of this thing are doing because last Wednesday I sat down with a whole pot of coffee and a magnifying glass and I followed all of the traces on the board. People go, Bother, how do you reverse engineer stuff? And I go, you work at it. Get back to work. You sit down with a pot of coffee and a magnifying glass and you get to know your circuit, and you have to get to know how to draw schematics in a predictable way, and you have to be a little bit of experience. You gotta have a little experience in knowing how things are laid out and structured, but generally in the world of microcontrollers, when you have something like a knob input coming from something that's not an encoder, you're generally using this as a resistor divider because that center tap of the potentiometer will just make two resistors, one on each side, and you put one to power, you put one to ground, and then you get a varying voltage level out of your potentiometer. So looking at the circuit, there's a resistor on one end, there's a resistor on the other, and then the common pin goes to a capacitor that's there just to filter out any sort of high frequency noise on the line, because you have to charge and discharge the capacitor in order to move that voltage up and down. So this is smoothed out by the cap. It's a very small cap, so it's probably not doing a whole lot of smoothing. It's probably just there for really high frequency transients. And then that voltage just goes right into one of the pins of the microcontroller. But it goes through a resistor first just to kind of keep the current from hurting your micro. I don't know how sensitive the STM32s are. They're probably pretty sensitive. But anyway, that's generally the structure of these things. Then they throw you for a loop with these pads. These pads know the velocity of what you're striking. And by velocity, I mean how hard you hit the button. The way that it knows how hard you hit the button, and this froze my stream the last time I tried to explain this. This is where last stream got completely derailed and I had to end the day. It took me 3 frickin' hours to explain everything that was going on. 3 hours to explain the whole project, and then I started to explain the weird curveball that these represent, and then stream froze. And so I raided you guys into Rob Oz. Anyway, these buttons are kind of like that shape. So when you press it down, it's kind of, so when you press it down, it just simply bridges two contacts. That means that in order to get from one end of this pad up into the short, back out of the short, through the other end of the pad, that means that this is the maximum amount of resistance through this resistive material. So you get a maximum amount of resistance with a light touch. The harder you press, the more the rubber settles down onto the pad, which means it shorts out a longer distance across that conductor, which means you have less resistive material from one end to the other. So as you press down more and more, it goes from a big resistance to a small resistance. And when you have a big resistance on power and a big resistance to ground, or a smaller resistance to ground, the ground is going to overtake the power and lower your voltage level. As this resistor shrinks, more power is going to be able to go into the line and the voltage level will go up. So it just makes the same thing as the potentiometer, only it's driven by pressure. PlayStation, Sony with the DualShock 4 does this for the analog buttons. Anyway, so that's how those work. These are just buttons. LEDs are just directly to the microcontroller. The knobs have actually gone through what's called a mux, which is just a chip where you give it a 1 and a 0 on 2 lines, and that will determine which input is connected to which output, right? It's one output, multiple inputs. And so if you just run through the numbers, 0, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, there's no 8. 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, and then so your fader here and your potentiometers can take up 1 pin of the microcontroller and then 3 control pins. This is an AB encoder. So an AB encoder, when you flip it to the right, 2 lines will have a pulse on it that overlaps a little bit. And depending on if the pulse overlaps one way or the other, depends on which direction you're going with the AB encoder. That's it. That's all it is. So that's everything on this board. So I will be able to program all those things, probably using libraries because I don't want to think about it too much. And if we can make a generic CAN bus device, we'll probably do it on this first. We can program it onto this, and then this will become our first sort of takeover of a CAN bus device to communicate with the rest of the system. From there, I can light up lights using the CAN bus signals. I can get button inputs using the CAN bus signals, so we can try to get Node-RED onto the Raspberry Pi, and then I will be able to test my ultimate plan. And if Node-RED is too slow, I've got to go to do that with microcontrollers. But I'd really rather have this interface. I don't know how fast Node-RED is when it comes to like signal routing. So anyway, let's pick up where we left off last time, huh? Last time we left off, I was just about to load up software into the micro. I had opened the schematic for the button thing, which I didn't really need to do, and I had just started to explain that resistor thing when... So let's go back to doing the tutorial. We hooked up the STM programmer, and I've got sort of a thing to follow somewhere around here. Sign on the dot. Oh, there's a pen tool. Cool. Whoops. Cool. Okay, anyway. Oh, this is driver downloads. I was in a state yesterday. There's bad things happening just because the RAM situation. I solved it though. It took a lot of climbing on the furniture though. A lot of climbing on the furniture. All right, so what are due? Let's see. So we're doing the Arduino IDE plugin. So let me open up Arduino. And we installed kind of an old version of the software, which should be fine. That should be okay. How's Twitch? Did I miss any like alerts or anything? Nope, just without it on. And then Velkin gave me a really nice shout out yesterday when we rated. MCP CAN. That's for the other thing. CAN bus, CAN bus, CAN bus. We don't need any of this stuff. I should probably close it. Hello ESP. What is that even doing open? So we have in our boards, we now have the STM32 boards, and we are doing a, oh boy, look at all this stuff. Discovery eval STM32MP1 32F3. Whoa. Board part number. Black pill. Wait, there's a STM. You really need to come up with new names. They have a blue pill and a black pill. Like, but those are like legitimate hardware, and I've seen people using them for projects. But like, guys, like the incels of, you don't want that. You really don't want that. You don't. I'm sorry that they've done this, but like, oh boy. So are we, wait, we're F3? STM32 F103. Oh, so we're not F3, we're... The boards seem a little bit scattered. I don't know if it's because we got an old version of it. We may need to put in that new, the new thingy-wingy, the new URL for the board manager. So it's an F1 series. Yeah, come on. Blue pill, F103C6. See, the different F103s have different pinouts. So for us, we are the F103. I mean, we could just tell it blue pill, but F103C8. We just want to make sure that we get the right pinout. Blue pill F103C8. C8 with 128K. There's generic 103, but we're blue pill F103C8. But are we the one with 128K? I don't know. I don't know what that fucking means. I'll just put in C8 because that's what we have. Look at all these inputs though. So many analog inputs. It's no wonder they use this for the MIDI pad. MIDI pad is all analog. I wonder if it miffed them that they had to put that 7400 series on the chip, because they are literally using every pin on that MIDI board. So let's try to get a Hello World going. Oh, what are the other things that we have? USB support. We're not doing HID, so we're just going to leave it at none. USB speed. Low speed's fine for us. Smallest, the optimization, like with the teensy and this thing, man, I don't know. New lib nano default. Oh, float printf. Float scanf. New libtard standard. Wait, so we're using new lib on my blue-pilled Arduino. Oh. The fact that I know these terminologies just from, like, clowning on dumbasses on the internet, and that I'm running into all of these stupid things while trying to program something completely separated, so far separated from that world that they're accidentally using all the terminology. It's bothering me. It's bothering me. It probably means I need to spend a little bit of time away from the computer. STM32Cube Programmer SWD, that's what we have. We have one of the clones. It was $14. I'm sorry, ST Micro. Your official programmer is $350. I'm not buying it. I would sooner desolder the chip from the board and put an RP2040 on it than to go out and buy a $350 programmer. The neo-lib standard. God. Program using the femoid board. Wait, what? Okay, so there we have a port, but our port is the cube programmer. So when we plug it in, it'll come up. I haven't plugged it in yet. Now we need some kind of a hello world. In the tutorial, there was a hello world. So let's see if we can find that. Follow instructions to install the IDE, select tools, USB support, select none. Cube programmer, SWD. This is all the settings that we just went through. It's all the same stuff. I'm gonna burp. Okay, I burped. Create an LED blink sketch. So what does that look like in STM parlance? Because I am worried about what the inputs and outputs are gonna be. And as soon as I know what those parlances are, we can take them over. Pin mode PB2. So we are using the name of the actual pin bank 2. So here, beep, beep, be prepared, beep, 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 what? Beep, beep, beep 2. Is beep 2 going directly to the LED on this one? This is a clone of a blue pill, so I don't know if it's exactly like a blue pill. Be prepared. Let's see, B2. I don't know why. Well, blue and black pill, I guess they call their board the pill, which is still a bad idea. And then it's the common silkscreen color. So you would have like a red pill. Wait a minute, no. Or a yellow pill. I just don't like it because it's so entwined in that stupid racist. Anyway, let's not totally get into that. So there's no B2, and I'm wondering if B2 is directly connected to the LED. That's probably what the scheme is here. I want to double check that just so that I know. Why isn't it pushing into this easily? The more pins you have on your board, the harder it is to get into these things. There we go. I'm just double checking for B2. Three, 15, 14, 13, 12. All right, so what is it? STM. Actually, Arduino blue pill schematic. This is actually the one that I have. Maybe they call it out in this. Blue pill pin perm. Tamper RTC. Weird. Boot 0, boot 1. B. PC 13, 15. Nope. Absolute max 150. 20. You would think there would be a call out for the LED somewhere. PA 14. Wake up pin. Reset button. So this pinout has everything, including little notes about what pins are 5-volt tolerant and not 5-volt tolerant. It shows the PWMs, it shows alternate functions, it has little notes about PC13. It does not tell you what the internal LED is connected to. Now, there is also Arduino sort of writing language stuff you can do in order to access the internal LED pin, but I'm just wondering if PB2, we can't find it anywhere on the pinout. I'm thinking that maybe that's wired internally to the LED. So let's get like the full schematic here. That might be the right one. Love if I could actually look at this. I don't know how old the blue pill is. Oh, we're gonna have to look at it. It's super blur vision. Yes, I just got a head injury and I'm PC13 for the internal LED. Which one is, wait, why is B2 called out? All right. Oh, that's boot 1. PB2 is boot. That's the boot pin. Why are we initializing the boot pin as an input? We don't need to do that. So this is why we look this stuff up. We look all this stuff up. So PC13 would be our output. This is there's a lot of explanation going on here. We're going to change that one to half a second because this thing already has a blink on it. And we need to know if our blink is actually going up into the device. So last time we hooked it up, we're pretty much picking up where we left off. We've got it hooked up. We plugged it in. The LEDs flashed. Now we're going to get our own hello world onto this thing using the JTAG port. I had a Wawa hoagie before stream, and I tried to give it enough time to like settle in my stomach, and it seems like that never happens, and I'm gonna stop eating lunch at some point. Yeah, I know. It's one of the what are those called again? I have to look it up because I don't remember what it was called. Shibboleth, which I'm sure I'm mispronouncing, which is actually quite ironic of the shibboleth. How do you pronounce it? Shibboleth? What is the upside down E in pronunciation? Apparently it's a Hebrew word. Shibboleth is a word or a phrase that the locals know how to pronounce in a certain way that people who are not local don't know how to pronounce. I will show you one from here. One from my local area. Knowing what a Wawa food market is one for the Philadelphia and surrounding area. Wawa's expanded pretty well, but there is a river in Philly. It's this one right here. Oh my God, every time I touch Google Maps, it has to load a new image. This thing right here. That word, you probably don't know how to pronounce. I'm gonna let it simmer for a little bit. Schuyllrive. Anyway, you probably do not know how to pronounce this, but I do. And generally that will identify somebody as being from this area or not. There's also another one a little bit west of here. Come on. Every time I touch it, it's got to load stuff. It's really annoying. Let's see. Where am I? I'm trying to go to... You know, you drive by the place all the time. You basically drive through the place in order to find it. And then for some reason you have trouble finding it on a map. It's so dumb too. Whatever, somewhere around here is Manayunk. That's another one of those ones that's hard. If I trace 70, there it is. There we go. Manayunk. We call it Manayunk. So the one that I was showing over here, that's the Schuylkill River. Schuylkill, not Schuylkill. Schuylkill River. Nope, it's a Schuylkill. The Schuylkill goes by Manayunk. So those are shibboleths. It's something that would identify somebody as being from an area if they knew how to pronounce it, because it's kind of very difficult to get it right the first time. Show ending soon. End card ready? What? The end card, I just used the technical difficulties as if something broke, which is what happened last time. Botort. Botort botatot. Botort botatot. Bota bada bada ba ba ba. Bada bing bang bing bing bo bo. Bee ba bee bo. Ha 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 ha. All right. If you didn't know, hamster dance was a big deal a long time ago. Anyway, that's what the word I was looking for, shibboleth. But anyway, remarking the SCM32. We've got all this stuff going on. Pin mode, PC13, output, digital write delay of 500, which is half a second, and then delay of 100, which is a tenth of a second. So the LED is going to go bop bop, or something like that. It'll be bop bop. I don't know what it's going to do. It'll do something other than just blink at a regular rate. Botatot is how it's said around here. For what? Wait, did you explain yourself? I can eat anything after that GERD med they put me on. Well, okay, Wawa's a local food market around here. It's where I got my hoagie from. It's pretty salty food and it all kind of tastes the same after a little while, but I haven't gotten it in a bit. Just because I've been kind of immobile because of all the snowstorms, I decided I wasn't going to drive around places and try to scrap together food. Oh, just a city in Virginia? I used to live in Nova. Of course, I say live in Nova. I used to work in Northern Virginia. I didn't even live, I actually worked in Quantico, so I didn't even, all I did was sleep in Northern Virginia for 10 years of my life. Did the hoagie use the right bread? No. Wawa used to use Amoroso rolls. Amoroso rolls are what make the cheesesteak a thing, because they've got this sort of cardboard, I don't want to call it cardboard, but it's sort of like a stiffer outer bread crust and then a pretty spongy, decently light interior. Makes a cheesesteak a cheesesteak. It really is the key ingredient. Wawa used to use Amoroso rolls. They stopped. They started making their own internal rolls. They're not as good. I was happy I missed shitty winter storm while I was in the hospital. Some of the nurses came to work side by side. Yeah, look, my father is in the whole doctor's situation. So throughout my entire life, my dad has always had to brave the snowstorms, and he has always had something like a Saab, like a 9.5 or a Volvo. Those were the options. He's never been a truck guy. He's never been a big SUV guy, and he's always gotten to work. Always. Like, so. Rip US sales of Saab. Born from jets, crashed to the ground. Saabs were really nice to work on sometimes, unless they did something really weird, like put a transverse engine into a car and have the transmission right below it. Saabs were awesome. I hesitate to call any car that uses vacuum pressure as its RPM gauge awesome. Awesome. All right, so let's get this thing programmed. Port. Okay, so this thing didn't show up as a port. We told it to use SWOOD. No programmers available for this board. Port. But it didn't, it's not COM4, because if I unplug this thing, COM4 is still on the list, so. Right, that's genius, not just awesome. It's so bad. Our vacuum pressure is not an RPM. Wouldn't that be affected by outside barometric pressure? When you're dealing with RPM and vacuum in a car, maybe it doesn't matter that much. And also, what are you doing with an RPM gauge? I think that was the sort of calculus that Saab took into effect on that one, is that, look, the vacuum pressure lags the actual real RPM. We're using the real RPM to control the motor, but what does the person driving the car need to know with that precise of a number? They don't. So if we just have it smoothly move through the system to tell you, yeah, it's spinning a lot, or it's not spinning that much, I think that's all the person needed to see. And then they put numbers on it, but the numbers are practically meaningless because it's vacuum pressure. But you know, that's what the driver is used to. So we're going to give them that. We know that they're not going to need to be at precisely 2,300 RPM. And when the technicians tune the car, they're not going to use that gauge. They will use something else. So it's one of those things where it's like, who am I building the thermostat for? Is it for my grandmother or is it for me? Because if it's me, I want all the numbers and I want them to be the real numbers. If it's my grandma, I can just say, hey, you want it to be kind of warm today, you know, and you can sequester the information to keep the consumer from being overloaded. All right, so I don't see, I'm not seeing the dongle. Let's see what happens. Oh, you know what it is? I need to put this into a boot mode before connecting it, right? So I need to flip some of these things. It's getting kind of cold in here. I need to close the window. Give me one sec. So being a streamer means you are eternally distracted. And being me means that you build things that also distract you even more during your stream. So the pace of our following this tutorial is glacial by design. But I stress that Hello World is one of the most important tutorials because it gets your entire command chain worked out. And then from there, you can do the business of actually inventing the device. So with your typical Arduino setup, I have been through just about every scenario in order to get the thing to become programmed and working and done. I do not have that kind of experience with the Blue Pill. So that's what we're learning today. But working alone, if I was just working alone, this would not be at such an abysmal pace. I'd probably already have this thing blinking. I want you guys to see what this process is like of learning a new system and getting it functioning. And then, you know, of course, moving on to devices like this. That write on PDF function is going to be so fun. I'm going to use that so much because, like, this looks like a boring official PDF, and then I drew a dick on one of the... That's just gonna keep making me laugh. That is value added. Thank you, Firefox. Why do we put this up? Oh, it's a datasheet thing. Okay. So click on the upload button to compile. Wait, but then it uploads it. And it had a COM port. So bootloader mode using both boot 0 and the N reset button. So is that boot 0 and boot 1? So we have to press both of them. That's going to be tough to do. We're going to have to figure out how to do that on the MIDI pad. So we set them both. Look at that, man. You remember having to set these things on motherboards? Not you, Copper, but everybody else does. All of the geriatric viewers of my stream. Some of them are likely to remember having to set parameters on motherboards with 10,000 of these little fuckers all over the board too. They weren't in one place. So we set that. I could have used one of these too. Oh, they're using the SparkFun FTDI basic board. That's the one that I like. This tutorial is so old that it has familiar tools in it. Okay, anyway, so we're using this one, and so we plug it in boot mode. I don't remember jumpers on the old laptops. Oh, you've worked on a couple. My favorite old laptop, because laptops never had jumpers because it was always just baked in, right? You didn't have the, well, I guess some of them you did have the option of changing the processor out, but I don't remember if I guess some of them probably did have jumpers for that. This old IBM laptop that I used to have, it was in my parts bin, and I took so many parts from it. It was wonderful. It used like normal surface mount sizes. It was very old. And every single function that the laptop had was with some kind of an ASIC. So you didn't have like an internal thermometer in your chip. You had a diode sitting below the chip. And if you trace out the diode, it goes back to an ASIC that was connected to some other kind of system bus thing. But that ASIC, look up the datasheet, and it was like diode temperature monitor. It had like a whole circuit in it that would show you how to hook this chip up to a bunch of diodes around your board, and those diodes would be used in order to test the temperature of various other devices. Really cool stuff. So if you wanted to just take that chip and plug it into an Arduino and monitor a bunch of temperatures, you could do that, all from this old laptop that, you know, used sensical design instead of modern super duper design where everything is baked into one piece of silicon. Okay, so now what we're going to do is plug it in, but with both boot things selected. I'm going to have to figure out how we do that with the other one, but plugged into USB, tools, port, still COM4. We still don't have, so why isn't our SWD programmer showing up? Blackmagic probe, HID bootloader, Maple DFU. So I don't think I have the ST tool open right now. No, it's not. Ho hum. Oh wait, what's going on with this then? This is the different method. That's the ST link. Compatible emulator and programmer dongle. Follow the diagram. Set the STM32 build to bootloader mode. Press boot 0, release. So this would be the STM32 cube programmer. We'll open that up and see if it recognizes it. It could be that we have too much USB cable on it. Accidentally bought an oil temperature sensor when placing an order for a water temp sensor. It was on sale. Haven't found a use for it. It's all haven't found a use for it. It's all stainless digital meter and plenty of cable. A nice cable of that. Interesting. Yeah. I don't know what you would do with that. Boop, boop, boo. So where do we select our board on this one? Over there. It's a different program. Oh, here it is. No debug probe connected. So that is the fault of my USB cable, I guess. I have it on an extension cable, but it may be too many devices. It might be behind too many devices. So let's try to plug it in directly into the PC. I can do that with these two USB ports that are kind of hanging out over there. I had to get into this computer yesterday to figure out all my RAM situation. I ended up running memtest, which is its own sort of gauntlet of stuff to get through. Memcheck, off of their website, they have like an auto USB flasher program. Don't use that. It doesn't work because it's not able to be recognized by UEFI. So I used a program called Rufus in order to burn the bin file that they provide on their website. Rufus was able to do it right away. And then I was able to run memcheck and find out that I had 2 different speeds of RAM in this thing. And there was also an error where if you have all the same speed plugged in, that first slot, if it's occupied, your computer won't post. So I had to go through iteration after iteration, put the RAM in, take the RAM out, do this, that, the other thing. I finally got it all working, and then I discovered that I had to do a BIOS update from Windows, because the one that goes automatically didn't work. Is this thing warm? What is that? Why is it? I guess that's getting warm. Doesn't feel warm. It feels a little bit warm. I guess I'm pushing so many LEDs out of this thing that it's not liking it. So anyway, I finally got the BIOS updated and got all the correct speed RAM in, and I ran memcheck 3 times and I got no errors. And then I booted Windows and I started up OBS and I ran it for the rest of the night until I got here today, and it's still running. Everything looks okay. What's the white fuzz? It's dog hair and dust. I need to just put my vacuum on it. Dog hair and dust. This shop is filled with dog hair. We've had the dog for 3 years, and yeah. No debug probe connected. Device changed, refreshing, port SWD. So that's connected. Oh wait, or not? Hold on. I think it does recognize now, so maybe we can find it in the Arduino ports. No. And the LED's on. And the SD Connect seemed to have done something. No debug probe. UR connection mode is defined with the HW reset mode. Warning device changed, refreshing. Oh yeah, the serial number is just a dot. How do I'm not supposed to update the firmware. I guess I'm gonna close this and then we'll unplug it and plug it back in. Why doesn't it show up? Yeah, Willow's 3. She's going to be 4 in the summer. My cats overheat my computer. The hair helps filter the dust through. Makes cleaning it simpler. Those are all like foam screens. They just show stuff really well. Next time I power up that little vacuum, I'll vacuum them out. That was one of the things about what I wanted to do with the rack that I haven't been able to achieve yet, is to be able to put the door on it and close it so that all the little chips and dust and stuff don't get into the equipment. Right now, we have basically an open frame computer, and it's been like that for a while. I dusted it the other day. I took it outside and I dusted it, but man, it is just open to whatever's floating around. So this is pretty common. You have trouble connecting your device. We have an ST-Link V2. When I plug it in, nobody recognizes it. Let's do the hardware mangler. Oops, is it hardware device mangler? That's right. And it's not going to show up as a virtual COM port. Standard serial over Bluetooth link COM4. Do we have unknowns? I don't see any unknowns. There is so much plugged into this computer that it is going to be difficult to find. Oh. STM32 ST-Link. Okay, so it sees it, but we don't have... I don't think we need to use this program in order to see it. I think we can just do it in Arduino, right? ST-Link, you should see target information in the bottom right corner. ST-Link Connect. Now close the STM32 and start Arduino IDE. Done. Cube Programmer. Oh, they don't select the port. bootloader mode using click on the upload button to compile and upload to the STM32 blue pill. Okay, so let's see if that just like automatically goes to the blue pill. Oh, I need to save it as, I guess it can go in there. STM32, hello. What are your guys' dump breaths? You're breathing all that into a stream, designing an air cleaning system would be good. That's what the computers are doing. Plus, I got mucous membranes. Listen, you're the only thing in the shop that can heal. So you really need to get between the workpiece and whatever's damaging it, because Boss Man does not have all the time in the world, and your mistakes are not going to heal. Put your body in between. What is it doing? It is doing a lot of compiling stuff. I do have the Dyson filtering fan, but I have that up in the bedroom. It's a little bit more pleasing to listen to for sleeping. Although the one I have kind of isn't. I kind of need to look for another one. It's full of mucus in the morning, so I'd change things. Yeah. What I do is I crack the window just slightly. If it were just me, I would be opening the window. I would be sleeping outside in a hammock. Application is running. Wait, what? Running program. Start operation achieved successfully. What? The LED is solid. Does that mean, is it done? Hello? Are you done? What if I take boot and reset off? I'm gonna restart this thing. This is just solid and quite painful at that. That is a very bright light. Look at that. Jeez. This should be going 1 per second. Per second. Let's see. Cut power, give power. Oh, there's a separate reset, I see. Wait, why do I have boot 0 and 1? Oh, I guess this chip has 2 boot things. That doesn't appear to have done anything. They said close ST Micro. I don't think I need to have Cube Programmer open, do I? Let's just see. I have not changed the filter on that fan. I'm just realizing I need to grab it and bring it down here and vacuum it. Does that mean it connected or? UR connection mode is defined with the HW reset mode. Software reset. Okay. Cool. Connect. Why is this not working? Upload. You know, it's possible that I have the wrong pinout for the LED pin. Gen F1, using Core Arduino, thingy. Start operation achieved successfully. Application is running, please hold on. I don't know. And again, once again, this is why we do this. This is why we do Hello Worlds. What in the fuck? Yeah, that says PC13, and so I defined the pin as PC13. You might want to check your code, it won't flash. Oh, look at that. Yeah, you're right. Why did they do it? This is why you define your pins. This is a shitty Blink program. It should be PLED, PLED. Oh my God, what did I just do? What did I hit a button and everything went crazy. I had control, I hit paste a couple times. I'm gonna move my soda. This is how the real programmers do it. That way, if you want to change your LED pin, you change it in one spot. There's also LED underscore built in, which is probably configured in this, but now upload that. We're not in programming mode. Well, I can get it in programming mode before this thing realizes it. There. Dun, 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 dun. There it goes. Doot, 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 doot. Now, just to make sure that we are in fact programming it, we're going to make it 1010, and the LED is going to go fucking insane. It may take a while to program. That makes it kind of annoying, but I mean, I'm going to see if this thing can reset and program itself in like all in one. And then we have to figure out how to do serial output through the SWD IO. From here, it just looks like a dim LED, but through the camera, you guys can see that it's kind of flickery. So we are now programming an STM32. How cool is that? We could go directly. I really don't have anything to lose here, which is kind of a weird thing to say when you're programming microcontrollers. But we have 3.3 volts. We have SWDIO. We have the ability to configure this thing into the processor that we want. We could try to upload this thing to the MIDI thing. I think I'm going to go pee because I went to Wawa. I had a whole bunch of soda. If you call it pop, you're wrong. What do they call it in Pittsburgh? Like fizzly wizzlies or some shit like that? They can't even call a rubber band like the right term. Call it gum band. Anyway, fingers crossed, no bricks. Oh, I'm all bricked up. No, wait, that's the wrong. That's not what I meant to say. Anyway, I'm gonna go use the bathroom real quick. All bricked up. It's gonna be like a. No, I'm not. I'm not. And then we'll actually program this MIDI thing. So you guys can watch a flickering LED while I'm gone. I have the BRB on this thing. This should work. Even this thing is covered in dust. Jeez. The Stream Deck is judging me. I mean, look at that. Yeah. Huh? Where did I put BRB? Oh, right there. All right. That's it. No BRB. I'll be right back. Way. I probably should have put on music for that. That's fine. That's fine. It's fine. I'm back. I'm back. I'm back. I need like a weird soundscape while I'm gone, and maybe once Julian helps me make noise with the synthesizer, I'll be able to hook that thing up as my hold music. But it probably won't be too pleasing, though. I don't know. We don't get that many viewers when Julian's here. We get a couple more, but it's I need to talk to them about making stuff that actually sounds like music. So we're gonna go back to 100. Gonna go back to 100. Then we are gonna open up my schematic from my favorite CAD program, MS Paint. I am gonna mourn the loss of MS Paint when I go over to Linux eventually. I guess we got to manually open it because it doesn't remember, but midipad.png. Here's how I reverse engineer things. You basically figure out what the device is, you draw a dick on the canvas, and then you go through methodically, piece by piece, and note down. And when I'm doing this for myself, I note down most of what I need to know, and that's generally pinouts and connections and schemes. I don't go through immaculate every single capacitor and resistor. I generally just look for the larger categories of component in order to put things together so that we know what pins go to what thing and how they are connected to one another. So in this case, we know which pins actually have LEDs on them. And some of my markings have kind of suffered from jostling the image around, but those are supposed to be P12 and P10. Or sorry, Oh yeah, the reason they're called, they're P is supposed to be pin, but in the case of the, wait, but those are E. Oh, but those are connected there. The P's are connected to, oh yeah, pad. They're marked as pad as P. So P8, 9, 10 it's not a pin bank. MS Paint should work with Proton and Wine. Do we really need to involve that? There's probably just a simple drawing program that I can pull in that'll be as dinky as MS Paint. Though it would be very funny to use the original MS Paint, so that's a good point. Okay, so LED stop, PB9. I'm not, well, I guess I am going to be saving this, so. All right, so I don't need any of these comments. This is over commented for a blink. When you get to my level, kids, you don't need all these comments on a blink program. You know, I'm pretty important. I kind of know my stuff, so. So stupid. This is like me with the Children's Activity Center. Going, when you're at my level, the little honking horn is beneath you. Anyway. Okay, so we are not the same processor. So our board is going to be SMT32F103. And then we are, what the hell? What the hell? What the hell is it? What were we again? We were like RB. RB, yeah, RB is right there. Hard to see. I'm thinking RB. So we're going to RB. Generic RB. There we go. And so that will now blink the stop LED once we hook it up. So now we gotta hook it up properly. And for that, I have the schematic over here to help. Yoink. So I put a line in there to symbolize the square pad as pin 1 being 3V3. I am gonna solder a header down. I should solder a header on this thing. It'll just make our lives easier. And when I put it back together, I'll cut a hole in your face. I'll cut a hole in the back of the panel because I don't think it'll stick out too much. And if a little bit sticks out, I'll just nip it. And that way we can put the thing fully back together while we're programming it. So we have access to the resistive buttons. Are you just, what was that? Oh man, why did I forget the name? Hold on, wait a minute. Why? Oh, that's an old man brain moment. I think I need to go see a doctor. It's, what's his face? Oh my God, why can't I remember this guy? Back when everybody was trapped indoors. Hold on, I just need to, hold on, I just need to. Demethil, there we go. Okay, I wasn't looking at anything. I didn't actually look at anything. Demethil used to let his daughter just throw emotes into my chat, and it's the cutest thing in the world. She just liked what certain emotes looked like, and she would just string them together, and it was so cute. If I really want to mark pin 1, because it's not really going to be that visible on this thing, I guess I could put a singular pin 1, check this out, using this stuff. Since I've been buying a bunch of little test boards, they've been sort of giving me this yellow header. So I'm going to mark pin 1 using the yellow header. Because I'm fancy. Look at how fancy I am, chat. Oh boy. Look at that. Beautiful. Okay, these are magnetized. Let go of the pin. Give me 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 the pin. Curse you. Okay. I love emojis. I did a Facebook pages about the art of them and GIFs before GIFs were on Facebook. Jeez. My MySpace page was that Northern English band doing the I Depend on Me. I depend on me. Do 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 do. Throw your hands up at me. Do 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 do. Throw your hands up at me. Oh, I got the wrong. That was the wrong. Girl, I didn't know you could get down like that. Charlie and your angels get down like that. Girl, I didn't know you could get down like that. Charlie and your angels get down like that. Listen. Anyway, I got the whole Flash plugin to run on MySpace and embedded that into my page. So I'm going to use this to align them so that they're not all cockeyed when we put it in. And then that'll be our pin 1 will just be the yellow pin. And so now I will not be confused. I will no longer allow myself to become confused. What is that? Mark used to block my techniques for GIFs. What, they didn't want to like host the bandwidth, I guess? All right, we'll do one pin and then we'll align it. And I got to be careful not to melt anything when I'm poking in there with my solder. Girl, I didn't know you could get down like that. Charlie, you angels get down like that. Listen. That's going to be stuck in my head for a month. Throw your hands up at me. That's actually pretty good. We did pretty good. All right, I'll just take that. It's a little crooked, but I'm not going to sweat it. So I'm only soldering the first 3 because I've got a plug on them. And so that plug will act as a heat sink so we don't melt the pins. And these are soldering decently enough. Well, this one's the ground pin. It's kind of harassing me. Not kind of soldered. You can see how the heat's spreading. They didn't put like a spready pad on there. I think what they had probably at the factory would be like a 5-pin pogo setup so that the pogo pins are sprung gold-plated pins, and they allow you to have temporary hookups. They're used in a lot of like factory setups where you'll plug a board into like a jig and then those pins will contact automatically. And so the person who's programming everything doesn't need to like know what they're doing. They just need to push a button. And that'll just load the hex file onto the chip. Or they do it with a ZIF socket separately. I'm not sure. There's a marking on the chip itself, which leads me to believe that they probably program them in a ZIF socket. I just wanted art and felt restrained to do so. So it became the art. There's a lot of that where you're restricted from something, and so your entire purpose becomes subverting that. What's art without limitations? Notes a lot of direct inputting became the vector for uploading. Another method was to sterning a file as an MP3. What? So you'd call it MP3, but then you'd call it up as GIF, and it would. That's funny. Jeez. Okay, so we got our JTAG quote unquote pins, which are connected to SWD. Not sure if they used SWD or JTAG, because this one's using JTAG MS, which is SWDIO, and this one's using SW clock, and then we have our N reset. I'm not sure, but anyway, we've got all these, so we can definitely hook this up correctly. Now that, see, the whole reason I purchased these was just to do the uploading. We're not going to use these in the rest of the system. Those two are just going to stick around in case I run into another STM32. These are what's going to power the rest of the system. The RP2040 is a much cheaper chip. It's much less obsolete. It's still a little bit obsolete. It's less obsolete. It also uses USB-C, and I kind of know it pretty well, so we can definitely get all the stuff we need done. The ST Micro we're only using because I have an ST Micro sitting in front of me, so boop. Where are we? Where am I? Oh, there we are. Okay, so do I need to connect and reset? If I just do clock, IO, ground, and 3, then I can use reset just with a pin connected to it. So pin 1 is 3, which is gray. So next one is Studio, which is the black pin. That's Studio. Next one is ground, which is the white pin. And then Swulk, which is 2, which is the brown pin. That's conveniently in line. Oops. You go here. You go here. And then reset, we will just use as its own thing. Let me find a connector for it, though, just so I have it. It's basically you connect it to ground, and it'll... Or do you? Yeah, I think you do. I think it's ground. Our virtual button will be played by the part of this wire. Girl, I didn't know you could get down like that. Charlie, you ain't just get down like that. Listen. Stop is... Which one? It's one of these. Oh, we've got like an LED over here. What's that one do? I guess there's like a little internal LED that says that it's powered or something. I don't know which ones that's connected to. Oh, and then when we're connecting it, we don't have boot 0 or N resets. Which pins are those? I have a full album of MP3s stored into an image file. Wild stuff, it still works. 60 megabytes. That's really good. 60 megabyte image. That's all of your... all GIFs for fooling Facebook. N reset we have. Boot 0. Boot 2. Pin 60. Which is 1, 2, 3, 4, 5 down. 1, 2, 3, 4, 5 down from the dot. The dot being not that way, but this way. Wait a minute, hold on. Pin 60. Those are the rows and the columns. And if the dot's there, then it's, okay, where's my pointing device? You don't need to do anything with the boot pins when you're using SWD via SW-Link. Boot pins can be left at zeros. Boot pins only needed if programming via USB or UART. That's good to hear. Okay, cool, because then we don't need to screw around with this. So 1, 2, 3, 4, 5. That goes to, actually, I think it's this bank. Wait a minute. Why is this all discombobulated? SW clock should be all the way over here. Also, my dot's in the wrong place? I don't know. Because I'm pretty sure I got this pin out and I double checked it. So it would be 5 over here. But I was pretty certain that this one was the boot, this capacitor over here. Or no, that's N reset. Okay, 1, 2, 3, 4, 5. R12? But that goes to something else. Am I just getting confused here? I think I'm just confusing myself. R12 goes way out over the whole entire board to God knows where. Okay, well, if we don't need that, do I need the reset pin? Do I need N reset? Because I guess I can connect that with just a jumper now. Because I can connect that to the programmer's jumper. I'm going to do it anyway. I'm going to do it anyway. I depend on meat. So many jokes like that on the internet of old. All right, so now we got reset plugged in too. All right, so let's try to completely erase, although, does this need an Arduino bootloader? I guess we'll just find out. Let's just upload. Oops. Okay, so it's compiling still. I'll let you guys know when things go down. I don't know if this will light up again. Compiling. This is still going to be a pretty frenetic blink that it does. It's going to be doot, 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 doot. All this to compile a blink program. All of the functionality and all of the memory usage of the ST Micro, all the things that Samson programmed in order to make this into a USB peripheral have now just gone out the window. They've been erased, or they are about to be erased. In lieu of Blink. Our pithy little Blink program that's gonna blink PB9. Start operation. And yet, I don't see no blink. Ain't no blinking going on here. Which could be that N reset didn't work. Start operation achieved successfully. Could it be that the ARM is locked? I don't think that's, I don't know. If we're going in through SWDIO, let me hit up that reset. I guess if I ground reset, it'll reset. And ground is the middle pin. That should have reset it. But I ain't see no blinking LED. Let's do a full reset. Well, that doesn't come on anymore. Girl, I didn't know you could get down like that. Darling, you angels get down like that. I don't actually know what that lyric is. I just know what it sounds like. PB9, which should be one of the LEDs, is not a blink. It ain't blink. And I'm pretty damn sure I got the schematic right. And we have the board is SWD Cube Programmer. F103 RB F1 series. So that's all correct. PB9. Hold on a sec. Let's double. PB9 goes to LED stop, which is one of these two. And it should be 100 milliseconds on and off. I'll turn it up to 5, just so we've got like a slow signal here. And let's try a different LED. 5 on, 5 off. Half a second on, half a second off. And we'll do PC10, which is LED pad 1. Do 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 do. Throw your hands up at me. Oh wait, the LED isn't on over here. Wait a minute. Trouble. If I just ignore that reset button. Oh, it probably backed itself out. Wait a second. There we go. Okay. What pad were we programming? We're programming pad 1, so that's this one. I ain't see no LEDs blinking here. Let us try initiating a reset. Nope. Okay. Try to prop this back up somehow. Throw your hands up at me. I want to do it like that because it shades it a little bit, so we have a better chance of seeing stuff happen. Won't program. Do I need to put it into a boot mode anyway? Is it in some kind of like a safety mode? I mean, I would assume they probably locked the chip. So maybe that's what we're running into, but we don't have any indicator of that. We just have start operation achieved successfully. I'm gonna try hitting upload again just in case. I had it unplugged when it tried to run the thing. We don't have a lot of feedback from the programming chain here. We'll see if this thing blinks. There it goes. Okay, so that either got rejected or uploaded. We don't really get any more information than a little blinky LED. From my experience programming this thing though, it just immediately ran the program and it would just start the program up. And in our case, the LED is not flashing and I'm pretty sure that I got the pinout right. Pretty sure. So that's trouble. STM32F405 have test software board, GPIs, and CAN. It was working well. Suddenly nothing worked at all. Also functions that were working before I tried to reflash my program. Flash memory seemed to be locked. Option byte can be set read locked and write protect flash sectors. Use the ST-Link utility. There's a facility to change the option bytes in the util. We found that changing the function of the SWDIO and SWD clock pins with the ST-Link attached can cause the option byte corruption and will wipe the flash. You may also want to set the brownout level to 2.7. So if I connect, I don't think I'm connected though. Yeah, I don't know if I can connect to this the way that we did the other one. Yeah, it's not giving me any info, so. That's for mutable instruments stuff. Here we go. Oh, I should probably connect that reset pin, huh? There. Not really working, is it? Okay, well, that's not connecting. Port SWD, something, 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 hot plug, access port 0, blah, 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 blah. Connect. No, see, it's just not working. Charlie, you angels get down like that. You sure, like, if, I guess, do I need to put it into a boot mode? Because in the instructions, I mean, we were programming the other board without putting it into boot mode. You're right about that. Although we did, I had them flipped on this one. So if I set them to 0, can I still program this device? This is how we're learning things. Well, we'll try that in a minute. I just want to make sure, because in the tutorial that I have, they told us to set those pins. Follow the above to install STM on Arduino IDE. Oh, okay. No, they don't tell us to do that. You're right. Create an LED blink sketch, set the STM32 blue pill to bootloader mode using, okay, yeah, see, look. Bootloader mode using boot 0 and N reset. I wonder, I think I probably do have to put it into bootloader mode so that it uploads the thing that SWDIO is going to use. Because maybe they have it configured for JTAG. I don't know though. So boot 0 and N reset have to be set to 1. We can get to N reset here, and we can hit it up with 3.3 volts here. Just have to be careful not to hit the 5 volts. They set those pins as the tutorial uses TTL adapter UART rather than ST-Link. But no, look. I mean, it has, these are the instructions for the TTL adapter. But here we're doing with SWDIO. So we're using the Cube Programmer in SWD mode, create LED blink, and then set the pins. Click upload. Which means that I need to solder, I guess, a jumper on here. Let's unplug so we can do this. I need to get to boot 0. Because trying to upload without those things connected isn't working. So something's got to change, right? I've run out of things to try. I've not had to move the jumpers on the blue pill that I have. But this is also something that might have been locked. I don't know if that makes a difference or not. I've never used these before. Here, back to the pinout. Girl, I didn't know you could get down like that. VDD, VSS, stop LED, row A, boot T0. I don't know why it seems to be connected to something via R12, and I don't know what it is. So let's trace that out. VSS, oh, sorry, VDD. VDD, VSS, LED stop, row A, boot 0. These are the hardest ones to trace. Well, it's 2 up. This one. This one goes up. Oh, so it's actually R11, right? Yeah, because VSS, stop LED, LED stop, row A, boot 0, Where's that one going? That goes to R15, which goes to ground. Okay, so it's got a 10K resistor on it to hold it to ground. Yeah, STM32F. 32F103. RB. We're trying to reflash it from the ground up. The 3v3 pin is usually board probe for voltage reference. What is that? Wait, what do you mean by that? Is the board powered externally? Yes. The board is powered. Yeah. Hold on. We'll just do a quick aside. So there is the USB slot, and it uses one of these hateful USB mini. Power's coming in, goes through probably either a surge arrestor, a flash arrestor, as static electricity, something, maybe a Zener diode just to cap it off. Big stabilization capacitor, and then it goes into an 1117 3.3 volt adapter. And then that 3v3 is the 3 volts for the rest of the board. This is just like a little, you know, pushy buttony device. Make sure those are separate. Eesh. Micro's not great. C is incredible. USB mini is terrible. Absolutely terrible. It's one thing that it was plagued with was when you plug these things in. This one's USB mini. When you plug these things in, it can push one of the pins back and into the body of the device, and that's usually the 3-volt pin, and it just shorts out your power supply. Is it powered externally when you try to flash it? Yeah, that's what this is doing. It's going in directly to the power pin that's on the JTAG programmer, which is, if we trace, this is our 3 volts. Donk. Right there, pin 1. USB 3 micro B. I used to work with those. Those are not fun. They're very unique. They're interesting, but they are weird. They're very weird. They just added pins to the side of the connector. So, oh, that was supposed to be question mark. Yeah, this is a big old capacitor. So we can hook and reset up to 3 volts. I got to be careful to get it on the right pin, or else we put 5 volts into it and then it dies. But now we can take that resistor and we'll just add a wire to it. And so let me get a little piece of wire wrap wire that we will then add to this thing in order to give it basically the jumper that it never had. I'm just rolling with the tutorial that I have to see if I can get it to take program, because we tried it without and it didn't work. So we'll try it with and see what happens. I mean, lucky for us, we haven't been able to program anything, so I could technically solder that connector back on and just make it a USB device again, but more fun this way. Yeah, it does. It has 3 volts and 5 volts. We got ground, 3 volt, and 5 volt at the bottom here. So using the N reset pin, instead of hooking it up to reset, I can hook it up to 3v3 through here, but then we don't have the boot 0 pin drawn out to anything. It goes to R15, which you can see the via right there, doesn't have anything surrounding it. R15 goes directly to ground. So what I'm going to do, not advised to connect a resistor, a 10K resistor between power and ground. I guess worse things have been done in the name of electronics, but this is a clone. It's not a genuine. I could spend $300 on an ST microprogrammer. Throw your hands up at me. Girl, I didn't know you could get down like that. That is going to be stuck in my head for a month. I guess it's better than most things that get stuck in my head. That's the rathergood.com. who did an interpretation of a band that does covers of things like that. And he made them kittens. But they were like Northern England kittens. They were wearing like whatever that hat is. And tweed. I got one used from eBay for $50. Felt nice having the real one, even if the clone works just as well. Yeah, I guess so. I had $50 though. $50. I don't work with ST that much. Maybe if I did, I would want like a genuine, but we do this kind of stuff. So it's better to be scrappy. Throw your hands up. That song is not going to leave my stupid dumb brain. Yeah. There we go. Those kind of work. It's not bad. Please add some flux. No. We don't use flux here. Flux is evil. Don't become addicted to it. It's gross and it's sticky. Plus, the solder is rosin core, so that brings in its own flux. Girl, I didn't know you could get down like that. Charlie, you just get down like that. This. I'm gonna have to like pull that up. I depend on me. All right, so now boot 0 and N reset are connected to 3 volts, or 1, which is the way they had it on this thing, and it's what the tutorial tells us to do. These rosin on bows and stuff, I wonder what it would be like to get a big chunk of rosin that's for like violins and use that for your electronics. Your whole place smells like pine. Now, theoretically, this will not blow everything up and I won't have to cry. Let's just give it a shot. It's even messier. Yeah, I would assume it's even worse. I don't use a lot of flux because the solder brings in the flux on its own. My solder brings all the flux to the yard. And, you know, it's like these YouTubers love things that look good that aren't necessarily practical when you're working with electronics every day. So they will drown a board in flux and do all these operations on it. And then they happen to have an ultrasonic bath to chuck the thing into. Right? I don't want to chuck this thing into a bath before I use it. We're just doing a little tiny jumper wire solder job. So as long as we just make sure to use new solder on the thing, it should coat the metal pretty well. And we can see everything flowed over nicely when I was doing it on the microscope. So the utility of flux, it's not like I don't have it within reach. It's just right there sitting next to the soldering iron. I use it selectively because, I mean, that shit goes up into the air and then you breathe it. And if you happen to go to the state of California and you have flux in your lungs, it'll cause cancer. So you can wash it with isopropyl. And while I do have isopropyl, I don't like overusing flux. I will use it, but I will avoid using it more than I do use it. And I think the content creators are to blame for some of people's lust for flux. Let's see if this actually goes in. Beep, boop, beep. That looked like ST-Link error, dev target reset error. Okay, dev target reset error. So unplug, plug it in, and P1 is not blinking. It would be very unfortunate if I had to buy another chip. That's funny. This seems to have put more text in than the other one had. We didn't get this whole splash screen here. I guess because it threw an error. Dev target reset error. Rossman. No, I don't think he's the main source, because if you've watched some other channels, they also, like, I watched a video the other day of somebody replacing some components on like some kind of a board, and it was on Reddit, and it was the people who didn't know a lot about electronics, and they're like, wow, what's all that liquid that they put all over the board? And that this person was literally using like a whole tube of flux in order to replace a couple parts, just so that they could do it in the really fancy way where you plop the thing down and then it aligns itself using the surface tension of all the solder there. And I think that's pretty disingenuous. It's basically just for, you know, showing off things in a very clean way when we're able to do things without drowning it in flux and have very good results. So I don't know what went on with that. It had some kind of an error. I'm going to try one more time, and then we'll have to figure out what's going on with a locked STM32R8. The alternative is for me to desolder the whole chip, which is, you know, doing what the YouTubers do and laying down a bunch of flux, getting the hot air on the thing, and then plucking it off of the board. Okay, so it's got like a target reset error that keeps throwing. If I connect reset, but I have boot 0 connected, does that affect it at all? Or does that, I may be putting it in like JTAG mode, but that didn't affect this guy. When I had them both set to 1, we were still using the thing just fine, and it didn't throw. Although that one has a boot 0 and a boot 1. We're hitting N reset and boot 0. Now we're just hitting boot 0. Maybe that's the key. He tells himself reassuredly, hoping that all hope is not lost. Don't like that it fully recompiles every time, although it is a little faster each time. Whoa! Whoa, 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 whoa. Racing internal memory sector 010, download in progress. File download complete. You know, it says all this stuff, but I ain't see no LED. I ain't hear no bell. P1 should be flashing. I think this is just power. I'm not totally sure about that. But all of our electronics are over there, so I gotta figure out what that LED is doing. That's coming off of one of the rows and columns. Yeah, I don't know what that LED is doing. But we're also not getting a flash. What if I reboot? Reboot! Rebuff! I don't think she took it. No, I think this is just the message that we got every time. Time elapsed during download operation 0000.758. Huh. It is only a blink program, but I ain't seen no blinking on this thing, and I'm pretty confident about my... Oh, disconnect boot 0 because it won't allow the code to run. Let's go ahead and power down before doing that. Hopefully now I don't need boot 0. That would be nice. Now that it's gotten the bootloader in there. Maybe. No. No, that ain't it. That'll put the chip on reset. Okay. You guys know STM way better than I do. It doesn't appear as though it's taken its code, though. Just in case. Upload. I know it's not going to do anything, but I'm going to try. See if I get any more information. Yeah, no flashing lights. 10.43 KB in 1/7 of a second. 6 volts, 4,000 kilohertz, Cortex M3. Yeah, I don't know. It's just not taking code. Used to work with PIX more. Yeah, PIX, when you set that security fuse bit, it really locks it down. Are there fuse bits for configuring internal versus external oscillator? That is an interesting point because there's no external oscillator on that one. This one does have an external oscillator, but we're using the generic, which I don't know if they expect there to be an oscillator on the generic. I mean, there's a lot of them here, but F103RB, USART support, USB speed, optimize, and upload method. Huh. We got to go into the boards file in order to figure that one out. Another possibility, assuming your hardware is okay, is a core lockout. When hard fault handler itself generates a hard fault, it's possible that they would have locked it, in which case we are out of the chip. Like, we can't do anything with the chip. In which case, I'm going to have to source one STM32F103RB. It's going to be like $12. RBT6. $7. They hate it when you order just one from DigiKey though, so maybe eBay. Common enough chip that I might be able to just find it on Amazon too. $22? Are you kidding me? Might as well just get it with a dev kit and then pull it. Does this one have an internal oscillator? It looks like it does. Oh, what a great photo. Thank you so much. That's a little better. 32F4. This isn't even the right chip. $20 before shipping, an $80 fee. No, there's a stock fee. Yeah, I think it's EOL. I don't know. This is a relatively old chip. Yeah. I don't know if there's a pin compatible chip out there that's more modern. It's not really account reputation. If you've got a small order, they tack like probably an $8 fee at this point, but I remember it as being a $5 fee for like singular items and stuff. It happens all the time in research. F103RC. What, RB versus RC? That's only $8. Let's check RB versus RC. Gotta close some of these things. So F103, where's that table of I think it's down here. F103. Wait, which one? Pin name type main function default. That's for the different pins. Where's the table of... I think maybe it's above. Whoa, 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 whoa. Too much momentum. Yeah, for DigiKey, they're filling like big industrial orders. So if you don't include enough stuff, it takes time away from, you know, you have a whole person going out there and getting the stuff, or you have a whole robot going out there and getting stuff. Can you connect with a reset pin to the N reset on the programmer too? Yeah, it is. That is programmed. That is connected rather. I have a feeling the chip is just like mega hyper lockdown, which is why I'm looking at getting another chip. Because the easiest thing for me to do would be to pull it out of some other board. If we get a test board, we could get our program running on it at first, and then just pop it out, put it in here, and then use it from there. Boot pins are used to select the boot options: boot from user flash, boot from system memory, boot from embedded SRAM. Bootloader is located in system memory. It's used to reload. Blah, 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 blah. Okay. Where was the thing that related us to the RB and the R whatever? Because those are the chips. Those are the pin functions per chip, and then we need the part number associated with the different packages. It's probably way down here. I think I just saw it, and yeah, here. Nope, that's not right. Nope, we're talking about timings there. All the way down. Dimensions for pinouts. Package information and marking. Oh boy, this is so this is a data sheet for an entire huge family of devices. When do these release? When do these come out? (2011, 2009). Yikes. So yeah, these are old. These are old. These 2007. Okay. So RC, what is that? Huh? 64,128. But if it's an R, then we have the right number of pins. So then the $8 test board is just what we need. It's just what we need. That's perfect. I don't know what C means. RC. 45, 256K flash. We're not going to need that. That means it's one up in the flash from the other one. This is because this data sheet is old enough that it doesn't have the C version. 256 kilobytes of flash memory. I mean, $8, sure. All right, so that's an order. You type C, yes. Oh, well, I guess you already did. That's what you put in the thing before you hit enter. Hey, everybody, type C STM32F103C8T6 into chat. This one's USB-C. I'm going to be pulling the chip from it. What do you want? It doesn't matter what it has. I'm pulling it. All right, I'm going to order this because my running theory is that. Hold on, I'm going to have to burp. Okay. I have bins full of USB-C connectors from OctoJ's pad repair session. They're at the very bottom of my storage. So I don't need these. Wow. STM32F103 RCT6. STM32F103 RB something something. But that's a B. That is a straight line on the left-hand side. So it is not an R8, it is an RB. But that designation is for the amount of flash memory. And so I guess we've got 256K of flash memory, which is cheaper with this weirdo little board that has an LCD connector on it. What I mean, everything else in the micro, it's the same like pin numbers. Yeah, my code can be really sloppy, and I do plan on using a lot of libraries, so. BGA, UFBGA, LQPIF, the package is important. The pinout is 64 pins. This one, T. Yeah, let's just make sure about this. This one's the T, which is the LQFP, so quad flat package, so leaded quad flat package. And this one is leaded quad flat package with 64 pins. I mean, this is a T. So yeah, this is everything we need. It's the exact same thing. You can write the program with Lisp. There's room for all the parentheses. I can do it in Ruby on Rails. Whatever happened to Ruby on Rails? You don't hear anybody talking about it anymore. Nobody talks anymore. This is supposed to be easy. Welcome to projects. We've discovered that our microcontroller is on mega super duper lockdown, which is not odd for a consumer device. But because it's a normal chip, that's probably what the RB on the... Motherfucker, have you been paying any attention? What do you mean probably what the RB means? R means 64 pins, B means 128 kilobytes of flash memory, T means LQFP. This one is an R, which means 64 pins, C, which magically means 256K of flash memory, T, which means LQFP package. So yes, that is what that means. It's not reading comprehension. I literally said it out loud. I've been saying it. I've been screaming it into the ether. This is why my dog does not come down to the shop anymore. I was just messing with you. No, you weren't. You weren't paying attention. You're just trying to save face, and that's okay. All right, so here's what's going to happen. I'm going to order this $8 part right now. I'm going to do it off camera. I'm going to hit buy now, and I'm going to have them ship it to... fuck, I got to enter my password. Hunter 2. Oops. Ooh, glad that second one worked. Saturday, March 14th. Oh, it's the 12th. Okay. It'll get here the 14th. What? That's so far in the future. And it's another $10. It was $10 for these two test boards, but these don't have the B package. These have the like C package or something. 32 F103, yeah, the C package. C8, it's still T. So I don't know if these were configured to have an external clock. The board that we just ordered, I didn't see an external clock. Hold on, let me take a look again. Document expired. No, I lost it. Okay, there we go. Learning board, blah, 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 blah. There's a crystal right there. Yeah, it's got a tiny little crystal on it. That might be the downfall of our programming here. We got to look at the boards manager and what those signals are to get it to use an internal crystal. So let's look at that now, and maybe my purchase of the other part was completely stupid. Should I desolder? I'm going to leave that on there. Yeah, let's take a look at the like the board layout files in Arduino, which I forget what the directory is. Let's wing it. Let's just try to find it manually. Documents, Arduino. This is where libraries is. This wouldn't be the right place. This would be Percent app data. I'm not going to know how to do this stuff in Linux when I switch over. I'll learn it eventually, but this stuff that's second nature to me. App data, local, and we go into Arduino. We don't have an Arduino in here. Local low? No. What are you doing, Microsoft? Let's see, roaming. Still no Arduino. I think Arduino works off of different stuff. Okay, AVR dudes? No, not there. Okay, so all that stuff, and then there's libraries. And maybe we're just going to C Arduino. C x86. Nope. Android Autodisk. All right, I'm gonna have to look it up. You get a second try? I guess so. Boards text. I did not need a copy of the file. I needed to know where the file was. Is in libraries? No, libraries is board platforms and cores. Oh, it was Arduino 15 in local. Why didn't I see it? Oh, because it was, I skipped over it. Okay, so Arduino 15 in local, and then we go to package, STM index. STM32. Hardware, STM32, 1.9. Cores. Arduino cores. Board dot, is it H? Is that the right one, or are we going to somewhere else? Hold on, let's just see what we got. Packages, Arduino, hardware. Whoa, 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 Control Z that. That was a misclick. Okay, yeah, so we're packages, STM32, hardware. And then we need to figure boards.txt. And so we go down until we find, oh boy, generic F1 RX R6 R8 65535, blah blah blah. Generic F103 R8 product line, and then the build variant is generic F103 RX. And we find generic. Oh boy. Let's put didn't find it. Where would it be? Oh, space generic. Space. Can't find it. Oh, because I used the full. STM32 F103R. Yo, that's that again. Wait, it's not referencing itself, is it? That's the only one it's finding. It's hidden. What? What's up? How you doing, Bridginky? What do you mean? I've got hidden files already visible on this folder. It is not hidden. It's boards.txt. So, Oh, we already got into app data by using the %app data thing. That just gets you into the... Okay. Yeah, chat is slow. Okay, that's not what I was looking for. I am supposedly messing with the boards.txt, but I'm not recognizing what I'm looking at here as much as I normally do. Usually there would be, I mean, board, product line, et cetera, et cetera, et cetera. But like, where are the setup flags? Build extra flags, build product line, build enable, USB, build X serial. And so I'm wondering how to set it up for no crystal. So I need to do the Arduino STM32 no crystal. Change crystal in the blue pill to the internal. Need to find out where PLL's set up. Have a grep for system core clock. The repository doesn't seem to have subsistence. STM32F103. There are RCC reset and clock control registers which select the clock source. Set the PLL multiplier, enable, disable the PLL, turn on the clocks to the peripherals, etc. Yeah, okay, so somewhere in here. Table 27 PLL characteristics. I don't know if it'll be table 27 or not. We have 37 matches in the whole thing for PLL. External clock is 8 megahertz and PLL when F clock. Okay. So internal. Internal clock. The parameters given in table 24 are derived from tests performed under ambient temperature. So those are just the characteristics of the internal clock. We got 5 matches on internal clock. T counter, 16-bit counter. So that's one of the internal counters. Internal clock source characteristics. That's the thing. HSI, high-speed internal clock. When HSI is used, PLL clock input, the maximum system clock frequency achieved is 64. For the availability of USB function, both HSE and PLL must be enabled. Wait a minute. So for USB to function, you have to use the internal, or you have to enable it. USB clock running at 48 to have an ADC conversion. Okay, I don't understand any of that. So those are just the characteristics, but that's not how to set it. PLL, phase locked loops. Phase locked loop. Characteristics. Wait, what was that one? Oh, that's just characteristics. Memory characteristics, PLL input duty cycle. Setup. No. Man, flags. No such terminology. Can an external clock be added? I do not have enough pins. What are they doing with the clock pins? I don't know which pins are the clock on this particular processor that we have. We can look at my reverse engineering. I think those are somewhere over here. Like these guys. What pins are they on this one? Because they're going to be kind of similar. Or not. What the hell? Are they coming from this bank? Which would be like up here. Those are already being used. Yeah, they used every single one of the 64 pins that are available on this thing. There are no extra pins. They had to matrix some of the buttons in order to save one pin. Or rather, 2 pins. Yeah, 2 pins. 4 and 5, yeah, they have LEDs on them, so I'm not going to give up those LEDs. We just have to figure out how to get the internal clock to be set up from the programmer, and maybe we'll be able to program this thing. That might be what the problem is. Chapter 7 in the reference manual. Ordering information. Okay, this might be just like hardware and timing specifications. So let's take a look at the reference manual from a Reddit page. Yeah, different document, much longer. Holy crap. That's not, I guess that's not chapter 7, but it's section 7. But that's not the right thing. Not quite. Clocks. 3 different clock sources can be used to drive the system clock. HSI oscillator, HSE, or PLL. The devices of the following 2 secondary clock sources. 40 kilohertz low speed internal RC. 32.768 kilohertz low speed, what is this? Is this even the right thing? What is this? Low density STM32 F10, F101, F102, F103 would be, I don't know if we're low or medium density or high. I think low density might be the 100 pin, and this might be the I don't know though. Doesn't apply to us. Cool. What the hell? It's like this doesn't apply to us. All right, so the Reddit thread sucks. Trying to run my first circuit with the STM32 microcontroller. For debug reasons, I soldered a minimum setup. No external crystal, only capacitors. I connect to SWD debug. I still cannot connect to the board. That sounds like us. That's us. He's like us for real. Oh, nitpicking. Just what they need to solve their problem. That's not an appropriate board layout. What? He didn't draw dicks all over it. You know, there's no dicks all over it. Your ground return paths are nowhere near your supply lines. Nitpicking. This is what you get on Electronic Stack Exchange. You get your nits picked. Low density applies to me, specifically my brain. Smooth, low density. I gotta move the fan. I'm like shivering. I like it cold, but there are limits on how cold. All right, so we're kind of hitting our head up against the wall right now. What I'm trying to do is find what little information might exist on running these things without an external clock. They decided on this device that it would be probably cheaper and it would have the same capabilities if they just did an external clock. So the external clock, or sorry, an internal clock. They use the internal clock, which the internal clocks on microcontrollers are typically not really that good or reliable. Having an external crystal that's maybe even temperature compensated, a TCXO, is really good for timing. You can do real-time timing stuff with that, but generally in the world of microcontrollers, we're not doing anything that garners super duper duper accurate timing. So an external crystal pretty much just gets you within the precision range to do just about anything you want. Your chat app didn't read my comment. What do you, huh? You're chatting in YouTube. What do you mean, my chat app? It's not no, my app is just for putting the comments up on screen. Ah. Yeah, it just didn't show up at all. I don't do, YouTube, I don't think allows you to do ASCII art. And if you're trying to do ASCII art, don't. That's too spammy. Too spammy. Okay, so advice about board layout, nothing to do with actually setting this thing. 3.13, clocks and startup. On reset, the 16 megahertz internal RC oscillator is selected as the default CPU clock. The 16 megahertz internal RC oscillator is factory trimmed to offer 1% accuracy, 25 degrees Celsius. Hold on 1 sec. I breathed wrong. The microcontrollers that I've dealt with historically have been like PICs and stuff, and I've firsthand seen what it's like for the microcontroller to do second by second timing. When you're doing large drawn out timers with something that oscillates at a breakneck speed, my impression is that the internal oscillator is really bad, because when you draw out those numbers all the way to the hours, minutes, and seconds, they're really off. But general purpose, it's probably fine for a lot of different things. And my impression of it being inaccurate is probably not fair to the manufacturers. Probably not fair. But they will always kind of gas themselves up in the data sheets. So the application can then select a system clock, either RC or an external 4 to 26 megahertz clock source. Some microcontrollers require setting up non-volatile configuration bits to configure the system clock source. Atmel uses Fuse. I guess that must be copyrighted by them. Based on this paragraph in the datasheet, it looks like the STM32F does not require an external crystal. Okay, we're already there. We know that it doesn't, because we have a device that functions, or used to, and doesn't use a crystal. Oh, lordy loo. 1% accuracy will be a performance limitation for some of the communications. Normally, we only use crystalless configuration in high volume, cost sensitive. So this guy comes in and he says, this is probably possible. They're like, hey, how do I... Is the crystal mandatory, was the question. So nobody's really helping with that. Maybe you should start with a ZIF socket adapter. Yeah, buy a $40 to $50 socket adapter. Can you explain how this answer is helpful? Nobody answered the fucking question. Okay. Arduino STM32, no crystal. Can I make it work without the crystal? RSTM32F. First time posting, blah, 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 attached to the daughterboard. Things should boot and run fine with the internal RC oscillator. It's also a low speed power internal oscillator, LSI. You need a low power mode. Consider the crystal HSC clock source if you want to strip timing requirements of the system. Thank you for the answer. The other individual said, as long as you don't do USB. As long as you don't do USB. I mean, technically we're not doing USB, but I can tell you, your little warning did not get to the people at Samson. I want to talk to Samson. Fly me to the moon and back. So, issue is solved. God, I hate the internet. How do I do this? There's got to be a way to do this, right? Although the question that I have is very specifically about the cores for STM32. So maybe we need to, here's the GitHub. That's what we need. That's a better link, much better link. Get out of here. You get out of here. You get out of here. You get out of here. We'll have a backup just in case. They moved it. No. Arduino command line interface. That's not what we're looking for. This Arduino platform specification for use of the Arduino developable software starting from the Arduino ID 1.5X series platforms. Add support, blah, 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 boards manager, platform installation directory, alternatively platform there. Vendor maintainer may have multiple supported. Let's see an example below. I'm gonna burp. Okay, I burped. I will listen. People listen to Twitch with headphones on, so I will mute when I burp. With all the nitpicking, this poor person's design, he should have just put some phallics in the design to keep them entertained. Yeah, it's like the internet versus the board that you design, right? People will nitpick every single aspect of it, and the fact of the matter is that this poor person just wants, they're not a poor person, they're just this unfortunate person. This broke ass bit. No, that's not what they are. But they're just struggling to try to get something out of their setup. So, although to be fair, that person probably should have gone to one of these dev boards that we looked at just now. Platform contains the definition for the CPU architecture used. Compiler, build process parameter, tools used for upload. Board's text contains the definitions for the boards. Board name parameters for building and uploading sketches. Programmers contains the definitions for the external programmer. So maybe we actually want platform.text. Yeah, that seems to be it, huh? Compiler warning flags, elf, etc. Build MCU, build flags. These can be overridden in boards. Build extra flags, build bootloader. Okay, platform.local. Build USB flags, Dustpecan. I'm just looking through hieroglyphics at this point. Customize the USB manufacturer product string. I did this for OctoJ. We had to go into our compiler stuff for the, what is it, the Teensy, no, not Teensy, AT-Tiny 85 for the 8-pin AT-Tiny. If you program them as a digistump, the DigiKey Arduino, you can actually redefine the USB stuff on it, and you can make it your own product. So he plugs it in, and it's the OctoStomp 2000 or whatever. Ever use USB value? I want to use it. Don't know enough about it. Yeah, so there's probably a more elegant way to do it, but I actually did look up all of those USB values and stuff in order to find what like a generic manufacturer would be and stuff like that. And you can choose like a random serial number and stuff. Pretty fun. UART module enabled. Build, enable USB, USB-C, Virtuio, startup file, flags, optimization, LD spec, and then flash offset. So I would assume something in the flags would be our, but I still need to like figure this out. I still need to figure this all out. Mass storage. Okay, so that's stuff we're not touching down there. That's the default. So we'd want to, of course, override these in the other folder, in the boards folder. I'm just looking to see if there was anything directly related. Boards.txt seems to be where we should be. And those are the menu options. And if I really wanted to go crazy, I guess I could choose I maybe could make it have a menu item for choosing whether or not it's an internal oscillator. You have to write your own system clock config function to override the built-in one. So I could put it in the Arduino code itself so that it wouldn't, because I was looking at it in terms of like putting it in the menus, but maybe we could just circumvent all of that stuff and put it in the code itself so that it overwrites whatever's going on there. Okay, hold on, I'm looking through. So, command line interface is an open source command line application in Golang. What the hell? What? Console applications for robots. Yeah, what do you got there? Let me see that. It's such a niche thing, but it seems like something that should have been built into the cores. How can the STM32F103C8 be configured to run with internal RC oscillator without external crystal oscillators figured in Bluetooth board with the Arduino framework and Platformio? I dug around a bit in the Platformio directory. The following paths are for generic SMT32C8.json, framework, variant. Sorry. Yeah, and then variant, and then, oof, okay, that's a lot. So that's Platformio specific, which I don't use, but the function that they added. Where's that? In your main.c++, initialize the CPU, AHB, etc. by using this. Why do they have a while one in there? Oh my God, Shortlurker has another link. This is complicated stuff. And I've seen it being done before in code where they have it. Oh, wait, the at the beginning. Excuse me, This would be the similar thing. System clock config. Oh my God. Just copy the function into your code. This whole thing? System clock config? Woof. That's a big guy. That's a big boy. So if I grab that and I put it into my very simple Hello World program, you know, why the underscore? Stick that at the bottom of your code. You don't need to call it yourself. The core calls it. Wait, so if I don't do anything here, it'll just do it when it boots? Huh. Weak linked. What does that mean? Goodbye. So it's an easy to override function. I see. I'm learning things. Did you know that? So, dear God, what the fuck is all this shit? I'm glad it's all here, but I'm just reading about it. HSI, HSE, DV, D1, V1, DV1, HSI on, PLL on, PLL source, HSE or div2. Oh my God. Okay. Why don't you light a few LEDs to see if the one on the pad is weird for some reason? It's not, because I'm good at what I do. And we know where PC10 is connected directly, so I'm so confident. I have no idea what any of this shit does. So is this already set up to use the internal? Is that what they were, because that's what the thread was doing, right? I dug around a bit on platform IO. Define your own system clock in your main C++. The INI then, that's for platform IO though. I have not yet verified the clock speed. It should run at 36 megahertz. The INI needs board build F CPU is equal to 36 billion L. Board build CPU clock. There's a way to override, I think, that on there, but we don't have a clock speed defined. High speed external, HSI is high speed internal. I see, high speed internal. So high speed external would be the other ones. I see. And then we would need to set the clock speed. I'm gonna quickly look that up. Arduino set clock speed. There's like a way to do this with overrides from what I remember in the regular IDE, because we're not talking about platform IO. And it's possible that the short lurker link explained that. You have to change FCPU only. You can add a new board in boards.txt. Bootloader. This needs to be recompiled with the correct FCPU and reflashed. I thought there was a way to do it in the code. Internal clock is 8. Multiplier is 9, so the speed is 72 megahertz, which is what you're expecting. Oh, so actually this gets it back to the speed that we would expect. That's not what they said in their comment. It should run at 36 megahertz. The INI needs boards build to be that. You're saying it's all in the function already, but they literally said that it's, unless they're setting it differently down here or something, or the original wants it to be. You know what? Let's just try it. Let's just see if it works or not. Because if it works, I'll be pleased as punch. Let's see. We're all hooked up and powered. I've got N reset. I do not have boot 0. Do you think I need boot 0? Do you think we need boot 0 on this thing? I'm gonna try it with boot 0. I'm gonna set boot 0. Because the times we set boot 0, it didn't matter. They said to divide by 2 to get 36. Do we need to take that out? Oh my God, look at all this crap. Look at all this crap. ADC PLC clock 2 div 6. Div 5. I don't see where they would be doing that. PLL mul 9. All right, we'll just try this, I guess. I don't know. And then, do I need boot 0? We're going to try it with boot 0 first. We'll try it first, and then I'll just see if I need it or not. If we can get it to work, then I just, you know, it's likely that boot 0 and boot 1 are doing nothing, and I have just been under delusions this whole time. I think it's more the clock thing than anything else. But with an external clock, we got it to program via SWDIO with or without the boot set. It didn't really matter where it was set. I'm just not sure if you're locked out of the chip, or maybe we're just not locked out of the chip. Maybe we just need it. Anyway, if it doesn't matter, I'll set it first just in case. And then we need that to be on reset or else it gets mad at me. Plug that in. We have a power LED. both on the board and on the programmer. There's the programmer. So I'm going to go ahead and hit upload, and it's going to take a minute to compile. Hopefully it doesn't kick back on any of the new code. All of these system overrides that we put in there, it looks like it didn't. So now we get through compiling. This thing does this blinky blinky, and hopefully we see that LED right there start to blink. Blinky blinky. Chat, is this real? I said it. I said the thing. I said the streamer thing. I said the streamer thing. I said it. Oh, I love you guys. Thank you. Ben Gizmo and Short Lurker. I have to credit Short Lurker too because he found the same thing. But you guys both are like so freaking on point. It hurts. I really appreciate your help around here because this would have taken me days. This would have taken me days, or I wouldn't have come to the right conclusion. I've got an $8 microcontroller programmer coming in the mail, and it's so obsolete that it probably was invented in 2007. So, whatever. Hey, look at that. It is running slow. As long as it can keep up with CAN bus. That's all it really needs to do. I don't want to have to put one of the big CAN guys on there. This thing could allow me to use an incredibly, like an impressively slow microcontroller. This thing hooked up to, well, we don't have enough pins to hook it up to SPI, so this thing is out. The MC, whatever the hell this thing is, you'll notice that it's got its own crystal because this thing is like an in-between for your high 500 KB per second CAN bus. It's like having two microcontrollers working on the thing so that this thing only listens to certain addresses. And then your actual microcontroller. Italian hoagie was a bad idea, but it's like always the only thing that I get because you get so much meat on the fucking thing. Anyway, point is, meat. No, so this thing is like your little man in the middle, person in the middle, and this thing looks at all the CAN bus signals that are fluttering about on the lines. Everybody's going and like communicating with each other at 500 kbps, and then this thing gets a signal and it goes, "Hey, micro, we just got a request and here it is." And the micro goes, "Oh, hold on a sec. Okay, let me see what the request is. Hey, I was doing that. Here's what it is," and then it'll send the packet back out, right? So this thing unburdens your microcontroller, whereas if I use the board that I probably have to use, where are they? Here it is. This one, this little guy right here only turns the TX and RX of CAN bus over to the micro. So on the USB lines for the STM32, we'll probably need to have a thread entirely dedicated to just looking at the addresses of CAN that are coming in and then picking out the commands that are meant to light up the LEDs or request buttons. I don't know if we'll have a request and response. It might just be that if there is a button change, our device will put out a button change and then get a button request. That might be how we have to do the handshake. Or if a button changes, maybe it just poops it out onto the line and then this guy will get it in and we'll filter it through Node Red. But man, that is cool as frig. So we can put this back together now. Now that I know how to program it, there's going to be quite a bit of writing in the background here. Maybe that's what we're going to be doing on Friday. But second, hold on, interrogative, second verse, same as the first. Let's get rid of the boot stuff. Let's get the boots out of there, because that's what I'm all about. I get it. The fact that it ran the program with boot 0 selected means that Ben Gizmo is exactly right, and we just don't need to worry about the status of boots when we're using the SWDIO. I think that may be the case. We need to change div 2 to be div 1, and then it'll be fast. Let's check. Well, actually, first okay, so we've had one success. What about second success? So if I plug this in, I guess P0 is also one of the pad 0. Kind of strange. I know programmers like to index at 0, but when you're talking about a physical thing, it's better to index at 1. Let's do 1 second beepity boop from this guy. So all I need to do is hit upload. Oh, this is cool, because it'll be nice and easy to program this thing, and then I'll have to figure out how I'm going to add like a plug to the side of it or something with 4 pins that'll plug it into the rest of the CAN bus. very, very cool. Hopefully we can do serial prints as well, but we're going to try to get it running at full speed first. Beep. 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 Yeah, okay, so it's running slower now. Perfect. So we can put this thing back together. Oh, no. First I want to div 1. Div 1 from div 2. So we're going to make this obnoxiously fast. Actually, that's normal hello world. And then I'm looking for, there's mul9, hallok, div 1, div 2, div 1, pb1 and pb2 clock. So we're just changing, we can't. We can't div 1. What is it? Because the pb1 clock divider, we're sourcing it from the PLL clock. I could have it tick the LED on and off every clock tick. We'd have to use the scope in order to characterize it, but that's going to be very hard to measure. We have to change one, but I don't know which one. Oh no. AHB clock divider. Timing functions will be off, as the implemented millis relies on some arithmetic that does not work well for the arbitrary clock speeds. You know, it seemed pretty decent for us on the timing that we were doing. That was supposed to be 1 second on and 1 second off, and I think it was half a second on and half a second off. It seemed like it was okay, though. It seemed like it was okay. That's actually going to be an interesting thing, because we'll probably have to put in some tweaky math in order to make it speak CAN bus at the appropriate clock speed, 500 kbps. So we're probably going to have to do some oscilloscoping. But I can button up this entire device and not have screws that are open and sitting around that'll get lost. So let's get cracking on this. I'm going to put this thing back together now that we sort of know what's going on. We're not going to mess with the dividers yet, because that'll have unknown consequences. What I need to do is get an external, well, a connection to an external thing on this. And then the next things for us to figure out is getting a serial print from this, so that I can characterize what it sees on all of its inputs. We know where things should be, but I want to know what the voltage levels are going to be for, you know, various pushdowns and stuff. And then from there, I have to develop a generic CAN bus program that can be transferred. Oh man, I can't believe I just spent those $8 on nothing. $8 whole just eaten. What direction does this go in? Oh, USB is over here. I'll have to open this up later and put some kind of a new connector over here. All right, what do we got? Let's see. I got a little marker right here. Like scratch the pins onto the surface. Now you have another dev board to do another project. The STM32s are pretty good. I suppose they're pretty fast, but they're also like really old. They're pretty old, aren't they? Like, at least the ones I'm working with. All right, so there's the hole. We want to have a nice hole around this thing. And I would like it to be square, but I don't know if it's going to be. In fact, I'm going to make it with a drill bit, so it's not going to be square. But I'm going to drill here and here, and then bridge it somehow. So let's get a drill, which I have. It's all the way over across the shop. One drill. And then I didn't cut these bits for plastic. These bits are cut for just generic use. Cutting a bit for plastic really makes this stuff much easier. I guess we're not really about easy around here. How big does it have to be? Probably no bigger than this. This one's probably good. Where's that pin header? Oh, here's a piece of pin header. Oh yeah, that'll be more than enough so that I can actually see what the, actually it'll probably be too big. Let's be clear here. Yeah, well, that has a little wiggle room. I don't want it to be sloppy though. Let's go a little smaller than that, and maybe that'll be okay. That side cutting Dremel bit would probably be good at this. Yeah, that's good. That's perfect. The one that cuts sideways, because you could drill it and then you'd have to be real careful and you could drag it to the other hole. Maybe not. I could also probably do it with a knife. I have a hot knife, but that's not that precise. This isn't that precise either. It's okay. It's the back of the thing, so you won't be able to see it. What is that dog barking at? The audacity of some of the people in this neighborhood trying to walk, being healthy. Can you believe it? These people. Willow will not stand for it. Cheese. Files? Microfiles? Kind of pushing it. We'll do this one. This is probably good enough. No, maybe not. Okay, we'll cut it first. I always use scalpel blades because they don't loosen up. I saw that one design channel that I love. They're trying to sell basically an X-Acto knife blade, which is a thing that you tighten from the back, and it's got the little thing that squishes. And like, I was kind of disappointed in them because scalpel blades do not twist off. And so a variety of different cutting can be done with them without the blade loosening up. I love using these things. They're so much more elegant than X-Acto blades, and they're cheaper. You can buy non-sterile scalpel blades by the bushel compared to brand name prices. So I'm just bridging these holes. This plastic isn't quite as soft as I'd like, so I'm not getting through the big bridge as quickly as I would have liked it to. But then I'll clean it up afterwards and we'll see what our alignment's like. I bet whoever's selling that board is like, jackpot! I finally got rid of that stupid thing. I guess if I accidentally blow this one up during development, I've got one in case. Oh, I see what's going on. I'm trying to cut through that stuff too. The 3M dual lock that I put on this thing so that I could put it into the other. See, the problem is I want to peel this stuff up, but both of my index fingernails are having a day after what I did yesterday with that ram. I don't know why it is that ram has to be designed like it's a gas station knife. Like, you're supposed to plug this thing in by pushing down on this. That's crazy. Oh, that left behind all kinds of goo. Oh, that's disgusting. Oh, I hate it, I hate it, I hate it. That's going to be so obnoxious. I need a file that I can actually fit in there. Remember to practice this on your own, at home. Well, it's somewhat ginched up. It's a little bit weird, but it is an opening. That's just a fancy heat spreader designed to make people pay more money for something that looks cool. Yeah, but the thing is, like, if you're getting Ripjaw memory, you don't need that on your Ripjaw memory. I don't think people chose that specifically because it looks cool. I think just the name Ripjaw is enough that people went for it, right? Because, like, I'm not out here looking for the coolest looking RAM. That's crazy. You look for something that meets your specs. I mean, if everything's in alignment, which it isn't, I mean, this is a really crooked hole. That's a nice hole. Thanks, I get that a lot. Ew. Okay, so we got to go down just a little bit, and then it'll be better exposed. So if I square off the bottom and then maybe the top a little bit, it should look okay. It's never going to look great. It's going to be kind of this torn hole in the back of the thing. You know, I could open up a big panel and then 3D print something to go on there. My DDR5 has a fan aimed at it? Well, you know, all the RAM that I've bought in the past, like, 10 years has had the heat spreader. But, like, you know, you can still get fancy with it, but it doesn't need to look like a gas station knife. Like, this looks like it's designed to cut you. Crazy. This sucks. This sucks. We're here forever. We're here forever. Square off the ends. Square off the ends, pull the whole thing down. That looks like a face. Oh, I threw up. People are probably walking their dogs right now. It's about that time. When everybody gets home from work, start walking the dogs. We're going to be doing a little bit more programming, I guess, with this thing on Friday, because I would like to get this thing to kind of get to the beginnings of speaking CAN bus. Well, I don't have the CAN bus outputs. I don't have anything attached out here yet, but I will just be using that little board. And this will allow us to reprogram it if we ever need to. I'm not sure if I can cut the pins to be flush, though, because we need enough of these pins so that they'll actually make contact. I probably could have put a female header here, like that, the female header material that I have, and then had something that plugs in. That may be the way I go. I could still undo this. Yeah, because those are sticking up kind of a little bit. Okay, so that is our programming port. I may want to go over to the female headers. Yeah, that's probably a better idea, to be honest. All right, let's do that before I move on, huh? That way the back of this thing will be nice and flush. Stick a razor blade inside this heat spreader and keep it in your car as a seatbelt cutter. Chad has the best ideas. The best. Their ideas aren't giving me cancer. Yoink. All right, big iron. Big iron. Big iron. And then we just kind of pull these through. Let's get, maybe, no, those will damage those. I need just something that I can, maybe just tweezies. Are tweezies enough to pull on those? I'm not sure. I'm trying to finish this up by the end of stream so that I have kind of a plot going today, because yesterday, or rather Tuesday, was a disaster. It was horrible. My computer froze, and it was because I was using 2 different speeds of RAM, and the BIOS was not updated. There was a new BIOS in 2022 for that board, and I didn't have it, and so I ended up putting in and removing again and again those RAM sticks, because in order to update the BIOS, I needed to boot into Windows, and in order to boot into Windows, I needed to have one of the slower RAM sticks in the first slot as like, you know, you must solve these riddles 3 kind of shit. Type of shit. That's what that was like. It's like a puzzle. And then I had to burn the mem test using a program called Rufus, which is typically used for like Linux stuff, because their program, their little USB flasher didn't like link up with UEFI. Like UEFI didn't trust it as a boot device. So I finally got into Windows. I got it to boot. I got my key working. And then I got the BIOS flashed. And then I put the regular RAM in, which bit me. It cut me. How could something like this possibly have cut my finger? It's implausible. It's completely impossible that something shaped like a gas station knife would cut my finger. But it did. I got mem test running, and I ran 3 total checks, and everything seems honky-dory on this computer. I left the desktop up overnight with OBS running, and it didn't freeze. So theoretically, oh, and also it boots a lot faster now, honestly. It boots a lot faster. So I think syncing up the speed of the RAM overall is a good thing. And I think maybe now we can stream without worrying about crashing. That was real nerve-wracking. Having your stream just kind of duck out and just stop was jarring. And the day of IT administration was very annoying too. Let's see what's going on here. Hopefully I'm not chewing these up too much. They look okay. This one is just never going to cooperate properly. Let's get this over here like this. I'm going to have to do the paint marker on pin 1 for this. Lots of heat. Lots of suck. Yeah, look at that. Beautiful. Beautiful. All right, so now female header. Let's get the females. I hate people who say stuff like that. We had one friend, we were out at a restaurant and everybody was talking very loudly, and he referred to females, and we were like, dude, like, dude, you gotta stop. You gotta stop talking about them like that. You sound like a space alien, man. Flow some of the good leaded stuff into there. Basically what I was doing is adding a little bit of solder so that when I do put the big soldering iron on it, there would be enough mass there to get the whole thing nice and gloopy and melty. Good, nice and melty. Okay, so some of these will only accept tiny little pins, so I'll probably have to make a, unless I use these. But these are special. Well, maybe I should use the special ones because these are going to stick. They're probably almost going to stick out. So yeah, this is a good use for them. This is a good use for them. Okay, so these rounded pin headers are like the premium ones. They really make a great connection, and they're really, really nice. I cannot find these. I keep buying these because I cannot find these. These have a larger hole. This hole is large enough that you can use the square pins with them. But they're probably not as compatible with the rounded pin ones. And I don't have any more fight in me. I don't have any more fight in me because I ordered so many of the ones that I don't like that I'm just stuck with them now. So if I do header to header, they're great. But if I do header to generic connection, I prefer to use the special ones, but I don't have any more of the special ones. It's a limited resource. It's a liminal funk. It's a put on. Sunrise. People forget. I'm sort of struggling with how to hold this thing up and get solder to it at the same time. It's put on. It's put on. Come on. Come on. Do it. Do it. Do it. Do it. There we go. Okay. Get one pin soldered and make sure that it's pushed down just lightly. It means that it'll be square to the board. I don't need a small soldering iron for this. I can just do it with the big honking one. Flood the tip. Then you don't get the flux. Although the pin is already coated, so that's probably acceptable. But yeah. Generally, you really just don't want to do flood the tip as your soldering method because that'll lead to bad results. Okay, there's a new programming header. Now I'm going to take a paint marker. Where's that paint marker? It's in my drawers. Not my underwear. Not my underwear. It's not my underwear. It's my drawer. The actual. It's like a drawer. Like a not like okay. It's put on. It's put on. I mean, it is kind of soldered. It'll be fine. So we mark that as pin 1. 10 minutes and he's putting on his drawers. Streamer, what happened to you? Woo, 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 Willow. She's going nuts at the door. It's getting to be that time when people are getting home from the day, so they start walking their dogs. And Willow starts going crazy at the door. But it's okay. That's a real slow. This is like shit. Don't rely on me to paint your Warhammer figures. It's not going to look good. I really need Gridfinity for that tool bin. The tool bin is very disorganized and it's very much just a lot of stuff in a pile inside of that thing. Ah, I gotta file more. Or do I? Or do I? Yeah, I should file a little bit up here. She is really at it, man. There must be somebody cool outside. Sunrise, we forget. I always love that song just for the intro part because it's all techno-y. And they used it on that Apple TV show, whatever the hell it's called. Now I want a Warhammer painting session. I have an airbrush, I have some precision brushes, and I've got a bunch of acrylics, but I don't think I'd be very good at painting them. I was going to use that for the RC car. Never got around to it. Also, I am so sick of Warhammer. I never liked it in the first place, to be fair. I never really got into it, but I'm also so sick of it. Ugh. Okay, there's plastic dust everywhere now. All right, that should fit pretty well. Let's just double check. Oh yeah, perfect. It's just got a little bit of wiggle room inside of there. So, cool. That's our programming header. And it's flush, which is an advantage. So we've got pin 1, you know, barely marked. That'll probably rub off. But if you could look at it from the side, you can see it from the side just a little bit. So that'll be nice and visible. All the schmutz that's on this thing, I'll have to figure out how to get that off. I can't exactly use Goo Gone because that stuff will eat away the plastic. But let's get the rest of this thing together and then we can start programming it tomorrow. We can just run a whole bunch of Arduino libraries because these STM32s are so featureful that there's no way in hell we'll be able to fill the thing with enough stuff that it won't be able to still function. I'm doing the ones that are circled. Yeah, there we go. No, there's nothing under that. Wait a second. Oh, it just sandwiches in. Okay, never mind. Oh, it actually goes this way. I see. I see what's going on now. Sunrise. People forget. Subliminal funk. It's put on. It's put on. I have to listen to that when I get home. Was there anything we needed to put in this before? Nope, we're good. We are good. Yeah, the PB oil dissolves the... Yeah, I can't use PB Blaster, no. And I can't use Brake Clean. I'd have way more fun casting, injection molding the little figures than painting or warhammering. I would probably like the painting because I printed out this little Enclave power armor when I was testing my goop printer, and designing and goop printing the figures would probably be pretty cool. This thing would be especially cool if I split it and I put a little coin cell battery in it, you know, like the Cyclops toy from the 80s, and maybe put a little button or something to make the eyes glow, or put a little inductor charger on the bottom there so that you could put it down on a base and it would, you know, glow. You'd have like a green glow coming from the fusion core. I ordered a sample from Formlabs and they won't stop calling me. What are they calling you? That seems kind of mean. Phone rings. Hello? You're a fucking jerk. Hey. They hang up. Nerd! They just hang up on you. Damn it, Formlabs. Got me again. Casting the plastic. Yeah, the 3D printing is like... Don't they have like rules against it in official tournaments, which is kind of silly? 3D printing is the solution to all of the nerdy needs to have little figurines that do stuff on a board when you roll dice. You can fully customize it. There's no other way to do it unless everybody suddenly gets $1 billion to buy all of these plastic molds. And the level of detail is insane. Like, mine is a previous generation flagship goop printer, and it was able to do like that detail. Look at the hatch and the little guard for it. And the tubes coming out of it. Like, I mean, that is a level of detail that you don't need much more than that, man. You can go higher. You can get like a better COD piece, but why? It looks perfect. It's a perfect COD piece. Yeah, and it's practically free. It's not exactly free. You have to pay the resin. You have to find a 3D model. That's one of the difficult things. Getting easier though, because everybody's sharing everything these days. Okay, so we've got all that stuff set up. Now we can put it in the enclosure. Am I going to need to get to any of this stuff? I don't think so. Well, yeah, I'm going to need to solder the thing on, but I don't want to lose all these screws, so let's all the screws and the knobs. Injection molding is great for making parts that don't delaminate. Toy making is an easy thing to help pay for the machine. I mean, people love their dragon statue figurines, right? I guess that's what most people who 3D print for a living seem to find out, that everybody wants dragons. What else? Like, I mean, what other like needs for toy building is there in terms of 3D printing? Because you would think if somebody needs a sufficient volume of stuff, they would just get their own printer. I mean, I guess all of the figurines that I'm talking about, that there's that system for designing them for like your D&D game. And I guess if they get the STLs, but then that company also has their own printing service, so you'd have to undercut them. I guess if you're doing a full-blown injection mold, yes. Maybe there's clients for that. I don't know how any of that industry stuff works. All right. Wait, oh, what, up, what, oh, that one. Clean up a little bit while we're here. Yeah. A lot of dust on this thing. Like I said, these parts have sat for a very long time before I actually got any use out of them. Looks like my numbering of these things is wrong. P3 was P0, supposed to be P0, but we got that one wrong. We'll have to run a bunch of tests to see which one is which. Okay. I'm pretty sure about the accuracy of the rest of my diagrams because I looked pretty closely at it, but we'll probably have to pull this thing apart at some point. Well, I am going to have to pull it apart to make the CAN bus connection, but first we can verify all of the button pins and try to get them printing on a serial feed so that I can see what the values need to be. Why would they put an arrow on this one? All right, what's going on here? There we go. There's no way it goes this way. No, that's stupid. No, it definitely goes this way. There we go. That's so weird. Why would it be like that? Okay, then to plug in, I need a pin header. So I need to grab one of these and just grab 5 pins off of this thing. One, two, three, four, 5. Yeah, there we go. 5 pins, 5 pins. Oops. Then that will plug in like this. And then I have my 5 pins. So I know pin 1 is 3 volts. So that's, which one is 3 volts? Gray wire. Pin 2 is, let's just get this done. Okay, I got to go over to my diagram here because I forget. PA13, which is SWDIO, which is second pin, which is brown. No, clock is brown. This one's the black pin. So black pin here. Next one is ground, which is, ground is the white pin. And then finally we have SW clock and then N reset. And I guess I can make an adapter for it some other time, or we could just continue to plug it in like this. So now I've got my programmer plugged in, and if I plug it into USB, the 1P pin will start blinking. It'll start blinking. Let's put all this stuff away. This out of the way. Probably could have put a right angle header on it. That would have been a better idea. Although propping it up on stuff is just the way that we're doing it. So, all right. And then if I plug this in, then we will get our flashing P3. Ta-da! So now none of this works, but we do know how all of this stuff is connected in, and we can start to build the software that will completely, yeah, exactly, a device takeover. We're going to take this over. We're going to make it similar to the shifter, where it'll get CAN bus commands in to light up the LEDs, and it'll send them out as you do the selector and the buttons and stuff. Pin 1, 3, or 5? It's 3. It's on the other side of the LM1117 3-volt regulator. The only pin that's 5-volt compatible is going to be the USB pin coming in. And since it's going into an LM1117, it's possible that I can also give it 12 volts, because all of our devices are going to be 12 volts, like automotive things. So we'll be feeding this thing with 12 volts. It might get a little bit warm, so maybe I'll want like a second regulator in there. But what we can do tomorrow is start to work out how we can get all the rest of this thing functioning. I don't think I'm going to need a fast clock speed, but once I get all of these buttons speaking serial out through the SWDIO adapter, then we can look at CAN bus and adding a CAN bus communication to thingy-wingy to it that will then speak to the rest of our bus. And then we can work on the Arduino, because we've got enough sources that I feel comfortable, you know, doing that part of it, and then we can start adding more devices and seeing what that does to the speed of everything. RCC, OC, int, struct, PLL, P, blah, 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 MU16. That's the code that needs to run 72 megahertz. All right, hold on. Control C. VAC the PC. Huh? Oh yeah, we're gonna be back tomorrow. All right, so let's does that just go here? Or RCC OC int struct PLL mul 16 instead of mul 9. .72 kilometers per hour. Save. I think I got the right units for that. All right. Hi. Hi, how's it going? I was going to play High Guard today, but the servers must be under maintenance or something, so we'll check tomorrow and see if we can play a little High Guard like we normally do on this channel. I'm done. We got everything that we wanted to get done today done. And I'm super happy about the status of this thing right now. We have a big block of code that allows us to use STM32s with Arduino cores. All right, that was just rude. Without oscillators on them, which is a weird thing. And we somehow were able to do it. Arduino has these little like catches where if you're an advanced user, you can jump in and you can redefine things. You can set flag bits and stuff like that. You can do it in the background, which is what I was trying to do with the cores, because you can add very easily, just add to things like the generic F103RB, or you could even add another tab on this thing when you select this stuff that comes up and says, hey, run with or without an oscillator. Or you can do a ton of weird override settings for stuff. And so we decided to go the route of the override settings. And as long as we remember that these are here, we can reference them again. In the past, I have done things like adding tabs to the selectors and stuff. But I think what we have going on here is perfectly fine. I think we're just going to continue on with it like that. Plus, you know, eventually I'm probably going to need to move up to the modern IDE for Arduino. My MS Paint / Notepad methodologies are kind of getting a little stale. Samson's not happy. Yeah, you can now just buy the Samson and follow this stream in order to... Wait, what was that? You can't buy this. There's one at like Sweetwater or whatever that place is, whatever that music store is. There's like one in existence. It's like $50. It's not worth it. There are offshoots of this thing, but I can't speak to what processor they have in them. But yeah, this is pretty cool. Just do small female headers on this one, and then that way you can just adapt it over to the other ones. Yeah, and use the ST-Link uploader and get all that proper processor code in there, and Bob's your uncle. You've taken over a device. Now, I've done a bunch of pinout reverse engineering on this thing. Everything was designed very simply. I don't know what other companies have done. These didn't sell well enough for them to continue selling them. So a bunch of other companies got similar designed things that probably do the same functions. They probably work in similar ways, but unfortunately, this can't be a DIY. This can't be like an instruction set. So anyway, I am gonna go. I will be back tomorrow. I'm gonna do the end card like right now. Let's see, admin. Where's admin section? Oh, it's not the right. You can find an old MIDI controller and translate the software. Yeah, I don't know. I don't know what because somebody linked, I forget who, somebody linked a similar one in my Discord, and it looked like it had the same structures. They were just slightly rearranged. Like the layout wasn't the same as the one I used, but it was similar stuff. So wait, tomorrow the March the 13th, and it's Friday. That's funny. The last time I did a command was the February 13th. That's March 13th. When did that happen? Okay. Did that do it? I think it did it. Okay, there's Nightbot. Okay, cool. So now I can just do and so there's the link to the Discord. It pretty much is my only social media these days. I was on Blue Sky, but it got hacked. Don't know what I'm going to do about that. I don't know if I can go in and fix that, but the Discord link's in there. And you have about 19 hours, 46 minutes, and 50 seconds until this channel goes live again. Be informed, be ready, show no mercy. Oh, and find the right button for the thing you're trying to swap to abruptly, because if you don't find the button, then it's just not a